Well, cast your mind back to February last year and you may remember the excitement when NASA successfully landed its Perseverance rover on Mars.
In preparation for parachute deploy. The navigation has confirmed that the parachute has deployed. Touchdown confirmed. Perseverance safely on the surface of Mars.
NASA's Perseverance rover has recently transmitted some astonishing footage from the Martian surface. The clarity and detail of these images have left both scientists and the general public in awe. This new visual data offers an unprecedented perspective on Mars, revealing areas of the planet that have never been seen before. Might this fresh footage help us get closer to unraveling Mars' history, or even hint at the possibility of life? In this exploration, we'll delve into the remarkable details captured by the rover that are reshaping our understanding of our neighboring planet. Rovers that revolutionized Mars. Exploration. The journey of NASA's efforts to explore Mars is a narrative filled with determination, innovation, and consistent progress. Although it gained significant momentum over the past 2 decades, the ambition to investigate Mars dates back much further. In the initial phases of space exploration, Mars was considered one of the most promising locations in the search for extraterrestrial life. However, reaching Mars was no simple task, and even after successful robotic missions orbiting the planet, landing on its surface introduced new challenges. This led to the groundbreaking idea of deploying rovers, a concept that would permanently transform our approach to studying distant worlds. Before we delve deeper, it's evident that the discoveries made by Mars rovers have been far more astonishing than anyone could have anticipated, and this isn't the only surprise in store. The inaugural Mars rover, Sojourner, touched down on the planet in 1997 as part of NASA's Mars Pathfinder mission. By today's standards, Sojourner was a small and relatively simple machine, but at the time, it was revolutionary. The concept of sending a mobile robot to another planet to perform scientific experiments seemed like the stuff of science fiction, yet Sojourner turned it into reality. Throughout its 83-day mission, Sojourner relayed a wealth of information about the Martian surface, including images and data regarding its soil and rocks. It demonstrated that rovers could function on Mars, paving the way for future missions. Building on Sojourner's success, NASA introduced a new generation of more advanced rovers. In 2004, the twin rovers Spirit and Opportunity landed on Mars, each assigned to explore different regions of the planet. Both rovers far exceeded their expected lifespans, with Opportunity continuing to transmit data for an incredible 15 years. These rovers made significant discoveries, notably the groundbreaking detection of evidence that liquid water once existed on Mars' surface, a crucial ingredient for life. Next came Curiosity in 2012, marking a significant leap forward. Curiosity was a much larger and more sophisticated rover, equipped with an array of scientific instruments designed to analyze the Martian environment in unprecedented detail. Its mission was to search for conditions that could have supported microbial life, and it succeeded in uncovering more evidence of past water, as well as organic molecules that could serve as the building blocks of life. Curiosity remains active today, continuing its exploration of the Martian terrain. The latest and most advanced rover in NASA's lineup is Perseverance, which landed on Mars in February 2021. Perseverance is not merely a successor to Curiosity. It embodies the culmination of all that NASA has learned from previous missions. It is designed to search for signs of ancient life, collect samples of Martian rock and soil for future return to Earth, and assist in laying the groundwork for human exploration of Mars. The footage it has transmitted is the most detailed and breathtaking view of Mars ever captured. The arrival of NASA's Perseverance rover on Mars was nothing less than a historic milestone. Launched in July 2020, the rover spent over 6 months traveling through space before finally reaching its destination. On February 18, 2021, Perseverance made its dramatic entry into the Martian atmosphere, descending to the surface through a carefully choreographed sequence of maneuvers that NASA scientists refer to as the 7 minutes of terror. This descent was not only nerve-wracking, but also incredibly complex, involving multiple stages to ensure the rover's safe landing. Unlike previous missions, the rover was equipped with high-definition cameras that captured every moment of its descent. For the first time, people on Earth could watch as a rover entered Mars' atmosphere, deployed its parachute, discarded its heat shield, and utilized a rocket-powered sky crane to gently lower itself onto the surface. The footage from this descent is breathtaking, offering a real-time view of one of the most daring and intricate landings ever attempted. This footage wasn't merely for show. It provided valuable data that helped engineers understand how the landing system performed. Every aspect of the rover's descent was meticulously planned and tested, but there is always some uncertainty when dealing with a planet's atmosphere as thin and unpredictable as Mars. The ability to observe the landing unfold in such detail has given NASA critical insights that will enhance future missions. As we progress in this narrative, you'll see how the rovers have improved and ushered in a new chapter in Mars exploration. Spectacular new perspectives on Mars. Once securely on the Martian surface, the rover began transmitting even more footage of its surroundings, providing the first close-up look at Jezero crater, the site selected for its potential to harbor signs of ancient life. Jezero crater is believed to have once housed a large lake, and the delta-like formations observed in the area suggest that rivers once flowed into this lake, carrying sediments that could contain evidence of life. The rover's arrival on Mars signified the start of a new era in exploration, not just because of its scientific objectives, but also due to the way it allows us to see Mars as never before. The rover's cameras are among the most advanced ever sent to another planet, and the footage they've captured is truly remarkable. One of the most thrilling aspects of the footage sent back by the rover is how it captures Mars in stunning high definition. Previous Mars missions provided valuable images and videos, but they were limited by the technology of their time. The cameras on older rovers simply couldn't achieve the level of detail or color accuracy that we're now witnessing with Perseverance. Perseverance is equipped with 23 cameras, many capable of capturing 4K resolution images and videos. This enables an incredibly detailed view of the Martian surface, revealing features that were previously difficult to see or comprehend. Every rock, ridge, and crater is visible in sharp focus, and the images are so clear that you can almost sense the texture of the Martian soil. One of the most striking elements of this footage is the color. While Mars is often referred to as the red planet, the footage shows that its surface comprises a wide spectrum of colors, from rusty reds to golden yellows to deep browns. These colors are not just aesthetically pleasing, they also narrate a story about the planet's geology and history. Different minerals reflect light in various ways, and by studying these colors, scientists can learn more about the composition of Mars' surface and the processes that have shaped it. The high-definition footage also allows scientists to study the Martian atmosphere in greater detail. Mars has a very thin atmosphere, composed mostly of carbon dioxide, and it often appears hazy in images taken from orbit. However, the rover's footage shows the atmosphere in action, with dust clouds swirling and faint winds sweeping across the surface. This is the first time we've been able to observe these subtle changes in real time, providing us with a new perspective on Mars as a dynamic, ever-changing world. One of the most dramatic pieces of footage sent back wasn't taken after landing. It was captured during the descent. Landing a rover on Mars is an incredibly complex and risky endeavor, often referred to as the 7 minutes of terror, due to the intense sequence of events that must occur within a short time frame to ensure a successful touchdown. This period, from the rover entering the Martian atmosphere to its touchdown, is a nail-biting experience for NASA engineers. During these 7 minutes, the rover had to decelerate from nearly 12,000 miles per hour as it entered the atmosphere, deploy a supersonic parachute to further reduce its speed, and then use a series of thrusters and a rocket-powered sky crane to achieve a soft landing. Each stage of this process was critical, with minimal room for error. If any component had failed, the rover could have crashed, ending the mission before it even began. What makes this footage so extraordinary is that it provides a real-time view of this descent, something never before captured in such detail. We can see the heat shield falling away, the parachute inflating, and the Martian landscape coming into view as the rover descends toward the surface. It's a rare and thrilling glimpse into a facet of space exploration that most people never get to witness. Now prepare to see Mars in an entirely new way, as every image from Jezero crater reveals more about this ancient planet. Craters reveal unexpected insights, enigmatic craters. As you watch the footage, you can almost feel the tension among the engineers at NASA's Jet Propulsion Laboratory as they await confirmation of the rover's safe landing. When the rover finally touches down, there's a collective sense of triumph, not just among the engineers, but for everyone watching. It's a moment that will be remembered as one of the most significant achievements in planetary exploration. Once on the ground, the rover immediately began its mission. Its cameras started sending back images and videos of its surroundings, offering scientists and the public their first close-up view of Jezero crater. This location was chosen because scientists believe it was once home to a substantial body of water, making it an ideal spot to search for signs of ancient life. The footage from Jezero crater is utterly breathtaking. The crater is encircled by cliffs and ridges, with large deposits of sediment that could hold clues about Mars' watery past. In some of the footage, you can see ancient river channels that once fed into the crater, now dry and eroded. These channels serve as a reminder that Mars was once a very different place, with flowing water and possibly even a climate capable of supporting life. Mars's landscape is incredibly diverse, and the footage from the rover showcases the full range of its features. From jagged rocks and boulders to expansive, dusty plains, Mars is a planet of contrasts. Some areas are blanketed in fine dust and sand, while others are strewn with sharp, angular rocks that appear to have been shattered by some ancient force. One of the most intriguing aspects of the Martian surface is its craters. Mars is dotted with craters of all sizes, formed by impacts from asteroids and comets over millions of years. Each crater tells a story about the planet's history, and the footage allows scientists to study these craters in incredible detail. Some craters show signs of erosion, indicating they were formed when water was present, while others are relatively pristine, recording more recent impacts. While Mars' beauty is undeniable, the footage also starkly illustrates how harsh and unforgiving the planet can be. The thin atmosphere offers little protection from solar radiation, and surface temperatures can plummet to a frigid -100 degrees Celsius at night. The images depict a desolate, empty world, devoid of life or vegetation, a place that feels both alien and eerily familiar. It's a sobering reminder of the challenges that future human explorers will face when they set foot on Mars. A primary objective of the rover's mission is to search for signs of ancient microbial life. While Mars is a cold, barren world today, scientists believe that billions of years ago, it was much more Earth-like, with rivers, lakes, and perhaps even oceans. During that time, the planet could have supported some form of life, and Perseverance is tasked with finding evidence of this ancient existence. The footage sent back plays a crucial role in this search. By examining the terrain in detail, scientists can identify areas most likely to contain signs of past life, such as sedimentary rock formations that may have preserved fossils. The rover is equipped with specialized tools that allow it to collect samples of Martian rock and soil, which are intended to be returned to Earth for further analysis. One of the most promising sites for this search is Jezero crater, where the rover is currently operating. Scientists believe the crater was once filled with water, and the delta-like structures suggest that rivers carried sediments into it, sediments that could contain evidence of life. By studying the sediment layers in these areas, scientists hope to uncover clues about the planet's past and whether it was ever capable of supporting life. Each new discovery brings us closer to the fundamental question: did Mars ever harbor life? Let's proceed to the next significant step in exploring the planet. A small helicopter makes a big impact on Mars. The quest to find life on Mars is one of the most critical scientific pursuits of our time. If the rover discovers evidence of ancient life, it would not only confirm that life once existed on Mars, but also imply that life might be more widespread in the universe than previously thought. Such a discovery could fundamentally alter our understanding of life's origins and our place in the cosmos. As impressive as the footage is, it also serves as a reminder of Mars's hostile environment. The planet's surface is a cold, dry, and barren landscape, with no signs of life as we know it. The images reveal a world that is both stunning and desolate, with towering cliffs, vast plains, and rocky outcrops stretching to the horizon. One of the greatest challenges in exploring Mars is its atmosphere. which is extremely thin and composed mainly of carbon dioxide. This makes it difficult for rovers and other equipment to operate, as there's insufficient air to provide lift or support for flight. The rover's footage shows just how dusty and windswept the planet is, with fine particles of sand and dust constantly blowing across the surface. Mars' temperatures present another significant challenge. During the day, temperatures can reach a relatively mild 20 degrees Celsius, but at night they can drop below -100 degrees Celsius. This extreme temperature fluctuation strains the rover's systems, which must be carefully managed to ensure continued operation in such harsh conditions. Despite these obstacles, the footage from Perseverance offers valuable insights into the Martian environment. By studying the planet's weather patterns, scientists can learn more about how Mars' climate has evolved over time and how it might change in the future. This information is crucial for planning future missions, especially those involving human explorers. The footage also underscores the importance of designing rovers capable of withstanding Mars' extreme conditions. Perseverance is equipped with advanced thermal control systems, radiation shields, and other technologies that enable it to operate in one of the most inhospitable environments in the solar system. It's a testament to human engineering and ingenuity, highlighting the incredible challenges involved in exploring other worlds. One of the most exciting components of the Perseverance mission is the inclusion of a small helicopter named Ingenuity. Ingenuity is a lightweight drone sent to Mars alongside Perseverance to test the feasibility of powered flight in the thin Martian atmosphere. If successful, Ingenuity could revolutionize how we explore Mars, allowing scientists to scout areas inaccessible to rovers and providing aerial perspectives of the planet's surface. After Perseverance landed, Ingenuity was deployed and successfully completed its first flight on April 19, 2021. This was a historic event, marking the first powered flight on another planet. The footage captured by Perseverance of Ingenuity's flight is mesmerizing, showing the small helicopter ascending into the air, hovering briefly, and then safely landing back on the surface. Since that inaugural flight, Ingenuity has completed several more flights, each more ambitious than the last. The footage from these flights offers a unique vantage point of Mars, enabling scientists to view the terrain from above in ways previously impossible. Ingenuity has flown over rocky outcrops, sand dunes, and other obstacles that would be challenging or impossible for a rover to navigate, providing valuable data that will assist in guiding Perseverance's movements. Ingenuity's success has far surpassed NASA's expectations and has paved the way for future missions that could include more advanced aerial drones. These drones could play a crucial role in Mars exploration, helping scientists map the planet's surface in greater detail and identify potential landing sites for future missions. The collaboration between the rover and Ingenuity is not only a technical achievement, but also a glimpse into the future of Mars exploration. As we continue to push the boundaries of what's possible, the footage from Perseverance and Ingenuity will remain a source of inspiration for scientists and engineers worldwide. Is the new footage from Mars merely an exciting discovery, or could it be revealing something NASA isn't telling us? Share your thoughts, and don't forget to like and subscribe for more updates.
Scientists were skeptical that we would ever be able to find these exoplanets because the stars that they orbit are so much brighter than the planets themselves.
An exoplanet is any planet located within our solar system, and some of these planets are free-floating, known as rogue planets. These wanderers move around the galactic center, while others orbit one or even two host stars. Astronomers first discovered exoplanets in the 1990s, and since then, thousands have been found. Now you can take a glimpse at them too. Spoiler alert, some exoplanets are extremely bizarre, while others closely resemble Earth and might even support life. The closest exoplanet to Earth is Proxima Centauri B, situated just 4.2 light-years away. Recently, astronomers have discovered that this world may be more similar to Earth than previously thought. It's only about 77% larger in mass compared to our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri B lies in the middle of its star's habitable zone, meaning liquid water and potentially life might exist there. It appears that the exoplanet is tidally locked with its parent star, so one side always faces the star, while the other remains in perpetual darkness. Scientists are still uncertain whether the planet has an atmosphere. It orbits very close to its star, completing one orbit every 11 Earth days. The star's radiation might be stripping away the planet's atmosphere. If so, Proxima Centauri B may not have liquid water on its surface. Another intriguing exoplanet is Gliese 832c, located 16 light-years away from Earth, a mere stone's throw in cosmic terms. This planet is 5 times as massive as Earth and orbits much closer to its parent star, resulting in a year that lasts only 36 days. However, since its star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c receives a similar amount of light and heat as Earth does. It's still unclear if Gliese 832c is truly Earth-like. It likely has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon happens when a planet absorbs more heat from its star than it can release back into space, making Gliese 832c more akin to the scorching Venus than our relatively cool Earth. TOI 700d is another Earth-like planet located 100 light-years away in the constellation Dorado. It orbits a small, cool dwarf star that's about 40% the mass and size of the Sun, with a surface temperature half that of our star. TOI 700d is the outermost planet in its system and is nearly the same size as Earth. It resides in its star's habitable zone, and no flares from TOI 700 reach it, increasing its potential habitability. This means it could possibly develop and sustain life. Scientists aren't sure about the exact conditions on its surface, but one computer simulation suggests it's an ocean-covered planet with a dense, carbon dioxide-dominated atmosphere, similar to what young Mars might have had. Another 3D model portrays TOI 700d as an all-land cloudless world, resembling what Earth might look like without oceans. Winds on TOI 700 days move from the night side to the area directly facing the star. In the Virgo constellation, there's an exoplanet that stands out due to its stunning magenta color, Gliese 504b. This world is located at a distance from its parent star that is several times the distance between the Sun and Jupiter. Having formed relatively recently, it still glows with heat, giving its surface a pinkish hue. Just 20 light-years from the Sun, which is relatively close in space terms, a bizarre rogue planet roams our Milky Way galaxy. Despite not orbiting any star, it possesses an incredibly powerful magnetic field, 4 million times stronger than Earth's. This exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers initially thought it was a brown dwarf, too large to be a planet, but too small to be a star. Later, they confirmed it wasn't massive enough to be a brown dwarf. This mammoth planet is 1.2 times wider than Jupiter, the largest planet in our solar system, and over 12 times as massive. Astronomers believe its exceptionally strong magnetic field helps produce its auroras, which are generated differently than those on Earth. It might be that the planet's moon assists in creating these spectacular light shows. Travel 20,000 light-years from Earth, and you'd approach a red dwarf in the Sagittarius constellation. These stars are cool and small. Far from this cold star lies a planet so distant that it receives minimal heat, making it one of the coldest planets ever detected. The average surface temperature is below negative 360 degrees Fahrenheit, covering the entire planet with a thick layer of ice. Standing on its surface, you'd see only glaciers, plains, and mountains of ice. Yet astronomers suggest life might exist deep beneath the frozen exterior because the planet's core could generate enough heat to melt some of the inner ice. This could create a vast subsurface ocean, potentially teeming with unusual life forms. One of the oldest known exoplanets is PSR B 1620-26b, estimated to be about 12.7 billion years old, nearly 3 times the age of Earth, which is 4.5 billion years old. This means the so-called Genesis planet formed just about 1 billion years after the Big Bang. It's so ancient that its 2 parent stars have evolved into a white dwarf and a pulsar, the latter making nearly 100 revolutions per second. Sunrises on this planet must be truly awe-inspiring. The next exoplanet is unlike any other you've seen, often called Super Saturn or Saturn on steroids. Known as J1407b, it boasts a colossal ring system that's 640 times larger than Saturn's. Located 434 light-years from Earth, It's the only planet we know with rings similar to Saturn's, but on a much grander scale. If J1407b replaced Saturn in our solar system, its rings would appear many times larger than a full moon from Earth. Astronomers have observed a gap halfway through its rings, suggesting that an exomoon the size of Mars might orbit within this gap. Living on this moon would offer an incredible view every time you looked up at the sky. WASP-12b is an exoplanet that absorbs almost all the light from its star, making it one of the darkest worlds known. It's a giant planet, twice the size of Jupiter, and traps over 94% of the starlight that reaches its atmosphere. This likely contributes to its extreme surface temperatures, which can soar up to 4,600 degrees Fahrenheit, almost half as hot as the sun's surface. WASP-12b orbits so close to its host star that it completes an orbit in just one Earth day. Its night side is cooler, but still scorching at 2,200 degrees Fahrenheit. The temperature difference causes water vapor and clouds to form above the planet's surface. Occasionally, material from its superheated atmosphere spills onto its star. About 4,000 light-years from Earth, there's an exoplanet that might be a gigantic diamond. It's 5 times the size of Earth, but takes only 2 hours and 10 minutes to orbit its parent star, a pulsar rotating at 10,000 times per minute. This planet is denser than any other discovered, consisting mostly of carbon so dense that astronomers believe it could be crystalline. If true, parts of the planet could essentially be diamond. On WASP-76b, it rains iron on the night side, and daytime temperatures soar to 4,300 degrees Fahrenheit, hot enough to vaporize most metals. This exoplanet is slightly smaller than Jupiter and is located 640 light-years from Earth. Its extreme weather is due to its unusual orbit. It's 10 times closer to its star than Mercury is to the Sun. Consequently, the planet and star are tidally locked, so one side of WASP-76b always faces the star, while the other remains in darkness. There's a bright blue exoplanet about 62 light-years away that's slightly larger than Jupiter. Though it appears calm and its blue color reminds us of Earth, this planet is anything but peaceful. The hue comes from silicate atoms and particles in its atmosphere. Wind speeds can reach up to 5,400 miles per hour, several times the speed of sound. Temperatures can rise to 3,100 degrees Fahrenheit. Worst of all, it rains glass sideways, making it an inhospitable place for a vacation. Here's a quick space riddle. Why is the search for life in the universe like a tree? Because we're always looking for a place to plant it. Okay, moving on. Water is essential for life anywhere in the universe, so planets that could support life must have liquid water. Numerous factors need to align for this to happen. The planet must be in its star's habitable zone, where temperatures and atmospheric pressure allow simple life forms to evolve. If a planet is too close to its star, water evaporates, preventing oceans and seas from forming, much like Venus, which is similar in size and mass to Earth, but too close to the Sun for life. If it's too far, the planet becomes too cold, and water exists only as ice on the surface, possibly with liquid water deep below, as is the case with Neptune. Additionally, the planet must be solid with an atmosphere that shields it from solar radiation and supports breathing organisms. In our galaxy alone, there are countless stars, literally uncountable. Each may host planets, known as exoplanets, some of which might be in the habitable zone with conditions ripe for life. Out of 4,500 known exoplanets, scientists have identified 24 that could be superhabitable. These planets might be even more suitable for life than Earth. Such planets would be twice as massive and 1.3 times larger than Earth. A bigger size means stronger gravity and a denser, warmer atmosphere, promoting greater biodiversity. The host star should ideally be smaller than the Sun, with a lifespan of 15 to 30 billion years, compared to the Sun's under 10 billion years. This extended lifespan allows more time for life to develop. Scientists suggest focusing on dwarf stars, which are smaller, less luminous, and can live between 20 and 70 billion years. Superhabitable planets would have different climatic conditions. The average temperature should be about 8 degrees Fahrenheit, higher than Earth's, with more water in the form of clouds, liquid, and humidity, conditions that favor biodiversity. Such a planet would resemble Earth's tropical forests, but on a global scale. All 24 candidates for better than Earth are over 100 light-years away. With new generations of telescopes, we may soon determine if life exists there and if the conditions are suitable for humans. Now let's explore some potentially habitable exoplanets. Teegarden B orbits a red dwarf star about 12 light-years away. Red dwarfs can emit flares that strip away planetary atmospheres. But this host star is calm. Teegarden B has almost the same mass as Earth and completes an orbit in about 5 days, meaning a year there is less than a week on Earth. The furthest potential habitable planet is Kepler 1638b, located about 3,000 light-years away in the constellation Cygnus. It's classified as a super-Earth, twice as wide and 4 times as heavy as our planet. Gravity there would feel much stronger, making even a simple jump challenging. However, if life exists there, it's adapted to these conditions. LHS 1140b is a very rocky and solid planet. Although only 40% larger than Earth, it's 7 times more massive, resulting in a gravity of 3.25 Gs. For context, during an airplane takeoff, you experience about 1.5 Gs. Standing up would be tough there. Its large mass gives it a thicker atmosphere, and due to the greenhouse effect, temperatures can exceed 19 degrees Fahrenheit. It orbits its star quickly, completing a full circle in just 24 days. In the constellation Aquarius, there's an ultra-cold dwarf star named TRAPPIST-1. A small planet in its habitable zone is 3 times lighter than Earth. Its temperature is similar to ours, but gravity is half as strong, which would make movement easier. Kepler 452b resides in a system resembling an older version of ours. Its host star is 11% older than the Sun and nearly 2 billion years older. The exoplanet itself is 6.5 billion years old. However, it's extremely far away. Traveling at the speed of the New Horizons spacecraft, it would take about 26 million years to reach it, so pack a big lunch. The closest exoplanet to us is Proxima Centauri b, orbiting the red dwarf Proxima Centauri, the nearest star to the Sun. It's just 4.2 light-years away. Similar in size and mass to Earth, it likely has an icy structure like Neptune. Despite being our closest stellar neighbor, Proxima Centauri is too dim to see without a telescope. All these planets, including the 24 newly identified ones, are in their stars' habitable zones. In theory, we could colonize them in the future. However, the major hurdle is distance. Even the nearest exoplanet is too far with current technology. Modern rockets travel at 5 times the speed of sound, but it would take over 100,000 years to reach Proxima Centauri. We need faster methods to reach these new homes. Perhaps scientists have an answer. Warp drive technology. This concept involves manipulating space and time to create a bubble where normal motion laws don't apply, allowing a spacecraft to exceed the speed of light. While it sounds like science fiction, humanity has theorized such technology, known as the Alcubierre warp drive. Since objects with mass can't reach light speed conventionally, the spacecraft would compress space in front and expand it behind, moving space-time itself. The maximum speed could be 10 times the speed of light. However, warping space-time requires an enormous ship and energy equivalent to what Jupiter generates. Recent calculations by NASA's Jet Propulsion Laboratory suggest the ring creating the warp field doesn't need to be perfectly round. It can be donut-shaped, simplifying design and construction. This could make it possible to test on a spacecraft the size of Voyager 1. While it still seems like a distant dream, scientists are optimistic. NASA plans to launch its first interstellar mission in 2069 to explore potentially habitable planets outside our solar system. There are also theories about achieving light speed with laser technology or using nuclear energy in matter-antimatter collisions, though these remain speculative. For now, we continue to explore and stay tuned for future developments. People often describe planets as massive, freezing, boiling hot, or seismically active. Rarely do we think of them as shiny, but there's a world called LTT 9779b that might be the shiniest planet we've ever seen. This exoplanet is ultra-hot and acts like a giant space mirror because it's enveloped in a thick layer of reflective metallic clouds. Located about 264 light-years away, the most astonishing feature of this unusual world is that it reflects approximately 80% of all the light its parent star emits toward it. In comparison, Earth reflects only about 30% of the sunlight it receives. This bizarre exoplanet is even more reflective than Venus, the shiniest planet in our solar system, which reflects around 75% of sunlight due to its dense clouds. LTT 9779b is 5 times the size of Earth, making it the largest space mirror ever discovered. This planet was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. Its highly reflective nature was uncovered later thanks to a follow-up investigation by the European Space Agency's exoplanet hunting spacecraft, EOPS, in a characterizing exoplanet satellite. Imagine a planet the size of Neptune but extremely hot, floating close to its star. If you stood on its surface and looked up, you'd see heavy clouds of metals overhead, raining down titanium droplets. The planet's size and extreme temperatures classify it as an ultra-hot Neptune. A planet's high reflectivity is known as albedo, and in the case of this shiny world, it's albedo puzzles scientists. Typically, planets that aren't icy or don't have thick, reflective clouds like Venus have low albedos because their atmospheres or surfaces absorb most of the starlight. Researchers initially believed LTT 9779b would have a low albedo, especially with surface temperatures reaching 3,650 degrees Fahrenheit on the side permanently facing its star. It was thought too hot for any kind of clouds to form, even metal or glass ones. Astronomers expected its atmosphere to be destroyed by the star, leaving a barren, rocky world, so discovering metallic clouds was a surprise. Researchers were eager to understand how these clouds formed. They compared it to how condensation appears in a bathroom after a hot shower. You can either cool the air until water vapor condenses or keep adding steam until the air becomes saturated. They concluded that the planet's atmosphere became oversaturated with silicate, leading metals to vaporize due to the intense heat on the day side. But the reflective nature isn't the only unusual feature of LTT 9779b. It's also an example of an extremely rare type called an ultra-hot Neptune. Astronomers have searched for such planets for decades. Its survival so close to its star might be linked to its high reflectivity. The metal clouds likely reflect light, preventing overheating and atmospheric evaporation. A heavy metallic atmosphere is also harder to strip away. About 850 light-years from Earth, a planet called WASP 121b orbits its star. This hot Jupiter is a gas giant extremely close to its star, resulting in average daytime temperatures around 5,000 degrees Fahrenheit. Like LTT 9779b, it has metallic clouds. WASP 121b has a bizarre oblong shape due to being tidally locked with its star. One side always faces the star, while the other remains in darkness, causing extreme temperature differences. This may contribute to the formation of metallic clouds. The water cycle on WASP 121b is bizarre. On the day side, intense heat breaks water molecules into atoms, which are then blown to the night side by winds reaching 11,000 miles per hour. There, cooler temperatures allow atoms to recombine into water molecules. The night side is cold enough for metal clouds of iron and corundum to form. When these clouds drift back to the day side, they vaporize, causing metal to rain down. Astronomers predict that WASP 121b may tear itself apart in several million years due to its fast winds and extreme temperatures. The star's gravity also stretches the planet, causing gases like iron and magnesium to leak from its atmosphere. The gravitational pull is so strong that the planet is on the verge of tidal disruption, which could eventually tear it apart completely. Just 20 light-years from the Sun, a bizarre rogue planet wanders the Milky Way. It has an incredibly powerful magnetic field, 4 million times stronger than Earth's. This exoplanet also produces stunning auroras. Initially thought to be a brown dwarf in 2016, it was later found to be too small for that classification. Nonetheless, it's a giant among planets, being 1.2 times wider than Jupiter and over 12 times as massive. Its strong magnetic field likely contributes to its auroras, which are generated differently from those on Earth, possibly with the help of a moon. Another planet you wouldn't want to visit is WASP 76b. On its night side, it rains iron, and daytime temperatures reach up to 4,300 degrees Fahrenheit, hot enough to vaporize metals. Slightly larger than Jupiter, it's located 640 light-years away. Its terrifying weather is due to its extremely close orbit to its star, 10 times closer than Mercury is to the Sun. The planet and star are tidally locked, so one side always faces the star while the other is in eternal darkness. In conclusion, the universe is filled with astonishing and diverse exoplanets, from Earth-like worlds that might harbor life to extreme planets with metallic rains and scorching temperatures. These distant planets challenge our understanding and spark our imagination about what lies beyond our solar system.
The Webb looks so far out that it's capturing light that's been traveling for over 13 billion years. But the universe has been expanding, and so the light has been stretching. And so for the most distant galaxies, we're looking back in time almost to the Big Bang.
When we peer deep into the cosmos using advanced telescopes, we're capturing light that has been journeying through space for over 13 billion years. However, due to the universe's continuous expansion, this ancient light has been stretched across immense distances. This stretching means that when we observe the most distant galaxies, we're essentially looking back in time, almost to the very moment of the Big Bang. The structure of space and time seems to narrow our observational field, funneling us into an ever-tightening cone of perception, as if we're being extruded through the very fabric of space-time. Recent discoveries suggest that our current understanding of the universe might need significant revisions. The James Webb Space Telescope, JWST, has uncovered findings that appear to contradict the Big Bang theory, which has long been considered the pinnacle of cosmic origin explanations. Renowned astrophysicist Neil deGrasse Tyson has noted that the JWST detected black holes from a previous universe, which may have been instrumental in creating our own. The James Webb Space Telescope is shaking things up. Suddenly, we realize that we might need to rewrite all the textbooks about how the universe began. Is it time to overhaul our cosmic comprehension? If so, how profound will these changes be? Join us as we explore the perplexing discoveries made by the JWST. Could there have been errors in the measurements, or is there a fundamental misunderstanding regarding the Big Bang? We'll delve into the newly discovered galaxies revealed by the James Webb Space Telescope. Formulating the hot Big Bang theory stands as one of the most monumental scientific achievements of the past century. This theory posits that our current universe emerged from an earlier state that was denser, hotter, and more uniform. Initially proposed as a plausible alternative to standard models of cosmic expansion, the theory was astonishingly confirmed in the 1960s with the discovery of the primordial fireball, now known as the cosmic microwave background (CMB). For nearly half a century, the Big Bang has been the leading explanation for how the universe came into existence. It relies on an inflationary period occurring before the Big Bang to set the initial conditions. However, astronomers and astrophysicists have long raised persistent questions about cosmic inflation and the Big Bang itself. Now, the JWST has introduced a new challenge to this narrative, adding complexity to our cosmic story. If it detects early galaxies that are significantly larger than expected, it could fundamentally alter our understanding of the universe. The JWST's discovery of massive galaxies in the early universe suggests that our current cosmological models may need reevaluation. These findings conflict with existing astronomical theories. Despite being operational for a relatively short time, the JWST has already unveiled previously unseen details about the cosmos in the first few 100 million years after the Big Bang. Starting with small groups of stars and dust, the traditional narrative suggests that structures in the early universe formed slowly. However, these newly discovered massive entities don't fit into that story. Lead researcher Ivo Labbé is intrigued by the apparent rapid maturation of these colossal galaxies. The common assumption is that big galaxies didn't form overnight, and this discovery challenges that notion. Astronomers have informally dubbed these objects universe breakers, a fitting nickname as they are reshaping our understanding of cosmic expansion. Although she wasn't directly involved in the research, English astronomer Emma Chapman from the University of Nottingham suggests that if these findings hold true, they could drastically alter our perception of the early universe. Discovering massive galaxies near the time of the Big Bang casts doubt on the idea of a dark cosmic age and raises the possibility that star formation occurred earlier than previously thought. However, scientists urge caution before we start rewriting cosmology's history. One theory is that some of these entities might conceal supermassive black holes. What appears as stars in the images could actually be dust and gas collapsing under gravitational forces. Another scientist, not associated with the study, points out that the complexities of black hole formation and growth during these early years remain a mystery. She suggests that the new evidence doesn't undermine cosmology, but rather prompts questions about how these objects formed and expanded. To confirm their findings, scientists can use spectroscopy to analyze the spectra of the detected objects, which would reveal their ages. Light from galaxies in the early universe has been significantly stretched on its journey to Earth, indicated by a high redshift. A higher redshift means the light has been stretched more, implying the galaxy is older and farther away. Spectroscopy can determine whether these galaxies, labeled as high redshift candidates, are indeed ancient, or if they are inherently redshifted galaxies from a more recent cosmic era. Astronomer Michael Boylan-Colchin provides his perspective. Despite the need for additional observations to validate the results, astronomers speculate that the observed mass represents a shocking discovery. Even if we reduce the sample size by 50%, the known stellar mass from this cosmic age could be 100 times greater than previously believed. In an unconventional viewpoint presented in Nature Astronomy, Professor Michael Boylan-Colchin from the University of Texas at Austin sheds light on the issue. The most widely accepted cosmological model, known as lambda cold dark matter, Lambda-CDM, suggests that in the early universe, dark matter and ordinary matter were extensively mixed. A portion of this intertwined regular matter transformed into stars as dark matter halos collapsed, giving rise to the first galaxies. Boylan-Colchin notes that the cosmic microwave background provides strong evidence for the distribution of matter in the early universe. To reconcile the existence of these high-mass galaxies, found by the JWST, he aimed to determine what fraction of ordinary matter would need to undergo starburst formation. He concluded that star formation would have had to utilize nearly every atom in the universe. However, Boylan-Colchin considers this near-perfect efficiency to be implausible. In contrast, he points out that the current universe operates at an efficiency of about 10%. Although not involved in the research, MIT's Mark Vogelsberger commended the theoretical approach of the paper. He remarked that the robustness of the estimate comes from relying on very few assumptions. So, is the Lambda-CDM model invalidated? Despite his calculations, Boylan-Colchin stops short of dismissing Lambda-CDM entirely, stating that no other theory matches its explanatory power, and replacing it would be a last resort. But are there other possible explanations at play? There are indeed mysterious findings to consider. Haley Williams, leading a team from the University of Minnesota, revealed a fascinating early galaxy discovered just 500 million years after the Big Bang. The faint appearance of this galaxy is also due to gravitational lensing amplification observed with the JWST. Compared to galaxies from slightly later periods, its rate of star production is tens of times higher. Williams points out that although this galaxy is less massive than those studied by Boylan-Colchin, she speculates whether this intense star formation could apply to larger galaxies at the same redshift. Nevertheless, Boylan-Colchin remains cautious. Given the object's small size, it spans only 1,050 light-years, much smaller than an average galaxy. He considers the possibility that it might actually be a globular cluster. Adjustments to the Lambda-CDM model are one possible solution to the tension in cosmological models. Early dark energy, EDE, theories propose altering the behavior of dark energy shortly after the Big Bang. This change could reconcile discrepancies related to the Hubble constant with other observations. According to these theories, the early universe contained more matter than currently believed. In this scenario, based on Boylan-Colchin's calculations, early galaxy matter densities would be quadrupled, eliminating the need for hyper-efficient star formation to achieve the same results. However, contrary to the 13.7 billion years estimated from other data, EDE models suggest the universe is only about 13 billion years old. Another possible explanation is that astronomers have misidentified stars as the source of some of the galaxy's light. Boylan-Colchin suggests that the light might actually come from accretion disks around supermassive black holes, which he believes is the most likely scenario. Since only a few of these galaxies have been observed so far, astronomers caution that the small sample size might not represent the entire universe. Professor Joel Leja from Penn State University, who wasn't involved in the study, notes that the observed tension could disappear if comprehensive statistical surveys are conducted. But are these galaxies truly so distant? Peter Beruzzi from the University of Arizona, also not involved in Boylan-Kolchin's study, points out that nearby low-mass galaxies can appear similar to distant massive ones. Additional measurements are necessary to draw definitive conclusions. Crucially, spectroscopic observations of these galaxies are still lacking, which would allow us to determine their actual distances and search for evidence of black holes. With new information emerging, Michael Boylan-Kolchin predicts that the severity of the issue will become apparent within a few years, if not sooner. In the meantime, we can consider astronomers' hypotheses about this phenomenon. There may be an as-yet unidentified process at work here. Some astronomers suggest that if we assume enormous black holes existed in the early universe, this puzzle could be solved. If this assumption is correct, we might finally understand the presence of large galaxies in telescope surveys. However, the challenge lies in explaining the sudden proliferation of black holes in the early universe. This is where a highly controversial hypothesis proposed by a Nobel laureate comes into play, an idea that stretches credulity. According to the currently accepted creation account, about 14 billion years ago, everything that exists was contained within an infinitely dense point. This singularity erupted, giving rise to everything in our observable universe. The Big Bang theory simplifies this concept, yet many physicists believe that 13.7 billion years isn't sufficient time for complex structures like superclusters to form. An Oxford University scientist is challenging the standard Big Bang theory, hoping to prove his points by analyzing remnants of the cosmic microwave background radiation, which was created when the universe was just 300,000 years old. This scientist proposes that the Big Bang was merely one event in a long series of similar explosions called eons, rather than the beginning of time. Each of these events marked a new epoch in cosmic history. Sir Roger Penrose, who was awarded the Nobel Prize in Physics in 2020 for his work on black holes and mathematical methods, has proposed that our universe has experienced multiple Big Bangs and that another one lies in our future. The mathematical techniques that Penrose helped develop led to the Nobel Prize, as they validated and expanded upon Albert Einstein's general theory of relativity. Regarding black holes, he explored their complexities and demonstrated how dense objects collapse under gravity to form singularities, points of infinite mass. Penrose reiterated his unconventional idea, calling it crazy when accepting his Nobel medal. As the universe continues to expand, he suggests, all matter will eventually disintegrate, triggering a new Big Bang and the birth of an entirely new universe. In an interview, Penrose expressed his firm belief that the Big Bang was not the beginning, but that something existed before it, and that something else awaits humanity in the future. So how does Penrose support his hypothesis, which he calls conformal cyclic cosmology? He claims to have found 6 hotspots in the sky, called Hawking points, each about 8 times larger than the diameter of the moon. These points are named after the late Professor Stephen Hawking, who theorized that black holes evaporate by emitting radiation. The existence of these points suggests that they could be remnants of evaporated black holes from previous eons. However, it's highly unlikely for such evaporation to be observed within the current age of the universe, which is 13.77 billion years. Penrose states that our universe is neither the first nor the last, but that it evolved from a densely packed, highly structured mass into the complex reality we observe today. Unless something occurred long before the Big Bang, the current inflation-based Big Bang model can't account for the presence of a low-entropy, highly ordered state at the universe's birth. As our universe continues to expand, it will eventually revert to a low-entropy state, approaching a final expansion into nothingness and leaving behind a cold, dark, featureless void. According to Penrose's theory, dead black holes, the remnants of past universes or eons, can be detected. Confirming this could also lend support to Hawking's theory about black hole radiation. In his 2020 paper covered by the monthly notices of the Royal Astronomical Society, Penrose found evidence of hot spherical anomalies in the microwave background. Data from these sites were validated through about 10,000 simulations and were sourced from the Planck 70 GHz satellite. In 2018, Penrose suggested that radiation hotspots in the cosmic microwave background could result from black holes evaporating. In a 2010 paper by Penrose and Vigersadian on cyclic cosmology, they proposed that the uniform temperature rings observed in the CMB are due to gravitational wave signatures from black hole collisions in a previous universe. Entropy decreases because black holes emit radiation and destroy matter. As the universe nears the end of its expansion, the last black holes will either vanish or merge, restoring some semblance of order. This process smooths out the space-time geometry from its current irregular state, bringing about a condition similar to the Big Bang. After the universe stops expanding, Penrose's model predicts that it will collapse into a highly organized system, marking the beginning of a new aeon that will culminate in the next Big Bang. Contrary to popular belief, Penrose argues that variations in CMB temperature shouldn't be random. He and Vigersadian discovered over 12 concentric rings in NASA's WMAP satellite data, which they suggest are evidence of gravitational waves from previous eons. If confirmed, Penrose's conformal cyclic cosmology would imply that our universe is just one of many potentially endless eons, eliminating the need for a Big Bang precursor. Though debated, this idea poses significant challenges to long-held beliefs in the cosmology community, and if proven correct, would have far-reaching implications. Some people find it hard to accept that the universe can transition from being infinitely large at one moment to incredibly tiny the next, implying that particles must lose mass as the universe ages. What are your thoughts on whether Penrose's theory holds merit, or if it's another Big Bang concept that will eventually fade away? For more updates, consider subscribing and leaving a like.
Hope we go back to the moon soon. We should have a base on the moon, like a permanently occupied human base on the moon, and send people to Mars, and build a city on Mars. That's what we should do.
In a universe teeming with enigmas and unexplored frontiers, Elon Musk, the visionary entrepreneur and founder of SpaceX, has consistently pushed the limits of technology and exploration. But what if we told you he believes the moon harbors secrets beyond our wildest dreams? Does Elon Musk possess knowledge we're unaware of? And is there a larger scheme unfolding? Join us on a mind-expanding journey as we delve into Elon Musk's psyche and uncover the hidden truths about Earth's closest celestial neighbor. The allure of outer space's mysteries continues to captivate humanity's brightest minds. This is why numerous space agencies have intensified their exploration plans for the coming decade. Nations like the United States, China, and Russia are deeply involved in these ventures. Even private companies like Elon Musk's SpaceX have joined the race, leading to collaborations among them. Recently, a fascinating partnership emerged between Elon Musk and China. Following leaks from the Tesla and SpaceX CEO, a startling discovery made by China on the moon's far side was revealed. This finding raises questions about what China uncovered and why it was concealed. Could this be evidence of extraterrestrial life? The China National Space Administration has been making significant strides in space exploration, challenging NASA's dominance. China has even built its own space station, adding to its impressive accomplishments. During their lunar missions, China stumbled upon a remarkable discovery, a secret that Elon Musk later shared with the world. In response, the China National Space Administration and the China Atomic Energy Authority issued an official announcement addressing the leaked information and revealing the astonishing news globally. The announcement disclosed that Chinese scientists, during their lunar research, made a groundbreaking breakthrough. They unearthed the sixth new lunar material, named Chang'e. This extraordinary mineral was discovered by researchers at the Beijing Research Institute of Uranium Geology, while examining surface samples collected by China's Chang'e 5 robotic mission. To confirm its uniqueness, the material was certified by the International Mineralogical Association and its Commission on New Minerals, Nomenclature, and Classification. Musk noted that Chang'e, belonging to the lunar marylite category, holds special importance. It marks the first lunar material discovered and observed by Chinese scientists, placing China alongside the United States and Russia as the third nation to achieve such a significant find. The mineral sample, a single crystalline particle measuring just 10 microns in diameter, was meticulously separated from over 140,000 tiny particles. It then underwent thorough analysis using advanced mineralogical techniques. The mission that led to this incredible discovery was the Chang'e 5 robotic expedition. This groundbreaking journey was launched from the Wenchang Space Launch Center in South China's Hainan province. After an awe-inspiring voyage, it successfully landed on the moon, becoming the third spacecraft in the 21st century to do so, following China's Chang'e 3 and Chang'e 4. This space mission, lasting 23 days, proved to be one of China's most daring and challenging ventures into space. Its goal was to collect lunar rocks and soil, and it triumphantly returned with 1,731 grams, a monumental achievement. Remarkably, it had been 46 years since the last lunar materials were brought back from our celestial neighbor. The China National Space Administration oversaw the distribution of the first batch of lunar samples obtained by Chang'e 5. These samples, each weighing 17.5 grams, were carefully divided into 21 lots and provided to researchers from 13 domestic institutions. These esteemed scientists were working on an impressive array of 31 lunar-related scientific projects. This accomplishment etched China's name into the annals of history. Collaboration was crucial in this monumental endeavor, as experts from various departments, including the Chinese Academy of Sciences, Ministry of Education, and Ministry of Natural Resources, united to study the moon samples. Their research revealed that these tiny moon crystals are over 1 billion years old, with a width comparable to a human hair. Such a profound revelation deepens our understanding of the moon's geological history and composition, paving the way for further scientific exploration and discovery. The remarkable findings from the Chang'e 5 mission left scientists at the International Mineralogical Association astounded. Their analyses confirmed that the tiny moon crystal has a composition unlike anything previously seen. It is intricately linked to other minerals found exclusively on the moon or within meteorites. These significant milestones have not only enhanced our understanding of the moon's origin and evolution, but also laid the groundwork for exploring the effective use of lunar resources. However, this astonishing revelation wasn't the only surprise from the moon mission. Another groundbreaking discovery caught the attention of Musk, a prominent advocate for clean energy. Among the approximately 140,000 lunar particles examined from the Chang'e 5 moon rocks, scientists found traces of helium-3. This form of helium is rare on Earth, but is believed to be abundant on the moon. It has been envisioned as a potential fuel source capable of revolutionizing the production and use of clean and efficient energy on our planet. This sheds light on why Musk chose to leak this information to the public. For years, scientists have been fascinated by helium-3 and its potential as a fuel for nuclear fusion, a remarkable energy production process where 2 light atoms combine to form a heavier one under extreme heat and pressure. The prospect of harnessing helium-3 for nuclear fusion has sparked great interest. Its unique properties and abundance on the moon open possibilities for a future energy revolution. Musk's decision to share this information signifies its potential to transform our energy landscape, paving the way for cleaner, more sustainable, and efficient energy generation. While fusion naturally occurs in stars' cores, scientists have yet to develop a fusion reactor that produces more energy than it consumes. However, helium-3 emerges as a highly promising fuel source, producing significantly less radiation and nuclear waste than other elements. According to Musk, helium-3 does exist on Earth, but in limited quantities. In contrast, it's believed to be more abundant on the moon, where the solar wind has deposited it onto the lunar soil over billions of years. The European Space Agency highlights that despite the lack of viable reactors to use helium-3, a lunar resource race has already begun. Numerous spacefaring nations and private companies, including the United States and China, have shown keen interest in mining the moon for helium-3. The discovery of a new helium-3 deposit by Chang'e 5 could accelerate the global competition to exploit the moon's mineral resources. This revelation has undoubtedly pushed the boundaries of space exploration and resource utilization. Beyond his endeavors in clean energy, Musk has revealed plans to establish human settlements on the moon as part of his vision to expand human civilization beyond Earth. His ambitious plans align with the growing belief that the moon holds great potential for sustaining human life. Moreover, Chang'e 5's further exploration of the lunar surface led to the detection of water. This finding raises the exciting possibility of humanity surviving and thriving on the moon. The presence of water opens doors for sustaining future lunar missions and establishing long-term human presence, further stimulating scientific curiosity and exploration. For many years, scientists believed the moon to be a dry, waterless, celestial body. However, thanks to the Chinese lunar lander, a groundbreaking discovery was made: water on the moon's surface. This isn't mere speculation. Scientists have confirmed water's presence on the lunar terrain. During its mission, Chang'e 5 collected over 60 ounces of soil and rock samples, unveiling not only rare minerals, but also the remarkable finding of water. Before returning to Earth, Chang'e 5 used its onboard instruments to take crucial measurements. Even from 239,000 miles away, scientists deduced that the probe likely encountered water on the moon. Water, vital for human survival, isn't typically expected in deep space. Its scarcity poses a significant challenge for exploring the final frontier, necessitating extensive preparations. This new discovery could revolutionize our understanding of lunar resources. To delve deeper, scientists conducted further research to investigate whether the trace amounts of water found could be harnessed by astronauts during extended missions. A team led by scientists from the Institute of Geology and Geophysics at the Chinese Academy of Sciences analyzed the wealth of data collected by Chang'e 5, seeking to unlock the secrets of lunar water. The intriguing findings from the data analysis revealed signs of water indicated by the probe's readings. Scientists identified H2O molecules based on how they reflected or absorbed the sun's radiation, known as spectral reflectance. These results impressed Dr. Meg Siegler, a senior scientist at the Planetary Science Institute in Tucson, Arizona. Dr. Siegler suggested there might be more water on the moon than previously thought. These ongoing discoveries have reshaped scientists' understanding of lunar water. Contrary to initial assumptions after the Apollo astronauts returned in 1969, believing the moon was entirely dry, subsequent missions have challenged this notion. The Indian Space Research Organization's Chandrayaan-1 mission, for example, detected signs of hydration on the sunless lunar surface. However, it was difficult to determine whether it was H2O or its chemical relative, hydroxyl. Casey Hannibal, a NASA postdoctoral fellow, compared hydroxyl to a substance found in drain cleaners, adding to the discovery's intrigue. Further missions uncovered ice in hard-to-reach craters near the moon's poles. These perpetually shadowed craters provide conditions favorable for preserving ice. Such findings prompted scientists to revisit Apollo samples with renewed curiosity. During analysis, water molecules were detected within glass beads and minerals in the samples, bringing both excitement and confusion as it challenged the moon's perceived dryness. Some scientists were skeptical, questioning whether the water originated from the moon or was due to moisture contamination on Earth. However, subsequent evidence emerged. A month before the Chinese lander's discovery, NASA announced the existence of water in a sunlit region of the moon. Without landing on the lunar surface, NASA achieved this by sending a high-altitude aircraft called SOFIA up to 45,000 feet. From this vantage point, SOFIA used advanced infrared technology to observe specific wavelength signals emitted by water molecules. The telescope's findings suggested water might be widespread across the moon, not just at the poles as previously thought. The mystery deepened when China's Chang'e 5 mission made another intriguing discovery. Besides shedding light on unresolved phenomena, the rover U2 debunked certain mysteries, including the so-called mystery hut found on the moon in November 2021. Initially spotted from a distance, the small square object resembled a hut, sparking curiosity. Scientists sent the rover for a closer look. As U2 approached, it became clear it wasn't a man-made structure, but an ordinary moon rock. The rock, later named the Jade Rabbit due to its rabbit-like appearance, had created an illusion through light and shadow. Therefore, Musk, the visionary behind SpaceX, is tirelessly working toward his ambitious goals, including helping NASA return to the moon by 2025. However, China also harbors long-held aspirations to establish a lunar presence, not just to claim a moon base, but also to propel nuclear-powered rockets into space in the future. They believe this will pave the way for colonization and enhance exploration of the final frontier. China's efforts haven't gone unnoticed, as they plan to build their first moon base by 2028 and send astronauts there in subsequent years. The moon base will be a remarkable feat, powered by nuclear energy to meet its long-term power needs. Its design will include a lander, hopper, orbiter, and rover, all constructed through the Chang'e 6, 7, and 8 missions. Wu Weiren, the chief designer of China's lunar exploration program, confidently predicts that Chinese astronauts will set foot on the moon within a decade. Regarding the use of nuclear energy to power the base, he asserts it's the best option for meeting the station's energy requirements. China's accomplishments have put them in the global spotlight, from successful lunar probes to building their own space station and preparing for Mars exploration. Their ambitious plans position them as formidable competitors to NASA's dominance in space exploration. Meanwhile, NASA continues to make strides, with a rover on Mars and plans to send astronauts back to the moon within this decade. Both China and the United States are investing billions in lunar missions, not only to explore the moon and its resources, but also to advance space travel to Mars. China's focus is on constructing a moon base at the lunar South Pole, deemed most suitable for accessing water, an essential resource. They also envision expanding their base into an international research station. With this goal, China has set forth a roadmap for robotic lunar and deep space exploration. Upcoming missions will deploy landers, orbiters, and relay satellites, testing key technologies needed for constructing the International Lunar Research Station in the 2030s. Initially, the ILRs will serve as a robotic base, becoming permanently habitable after 2035. In the coming years, China is set to make significant strides in lunar exploration. Building on the success of the Chang'e 5 mission in 2020, Chang'e 6 is planned as a follow-up mission for 2026. It aims to retrieve up to 2 kilograms of material from the lunar far side's South Pole Aitken Basin. To overcome engineering challenges, the landing site will likely be near the same latitude as the Chang'e 4 mission's landing in the Von Karman crater. A new lunar relay satellite will be launched to ensure seamless communication, targeting the moon's South Pole vicinity. Around the same time, Chang'e 7 will launch, equipped with an orbiter, lander, rover, and a mini-flying detector. This comprehensive mission will study lunar topography, material composition, and the environment. The mini-flying detector will play a crucial role in identifying water ice, focusing on permanently shadowed areas in the lunar South Pole. These missions aim to unlock the secrets of the moon's unexplored regions. Looking further ahead, Chang'e 8 is projected to launch by 2028, serving as a testbed for in-situ resource utilization and 3D printing technologies. This mission signifies China's commitment to exploring the potential of utilizing lunar resources and advancing cutting-edge technologies. China is also preparing for a crewed lunar landing in 2030, planning to send 3 astronauts to the moon. This ambitious endeavor will involve 2 launches of a new generation crew launch vehicle. 2 astronauts will have the opportunity to set foot on the lunar surface for about 6 hours, conducting experiments and gathering valuable data. Both lunar landers and spacecraft for this mission are currently under development to support these extensive plans. The China International Lunar Research Station will be established in the early 2030s. The ILRS will see 5 launches dedicated to placing orbital and surface infrastructure for energy, communications, resource utilization, and other advanced technologies. These missions will require the lifting power of the Long March 9, a super heavy lift rocket. Excitingly, Chinese officials have announced they're redesigning the Long March 9 to make it reusable. While it's certain that Musk is involved in lunar projects, it's also clear that the Chinese Space Agency has a bright future ahead, with numerous discoveries and advancements on the horizon. As this journey into Elon Musk's enigmatic world and his discoveries about the moon continues, one thing is abundantly clear: the moon isn't what we thought it was. Musk's vision and relentless pursuit of knowledge have opened our minds to a universe of possibilities. Experts suggest that the moon's secrets might just be the beginning, and our universe remains full of awe-inspiring wonders that could shake the very foundations of our understanding of the cosmos.
Since late last year, now the James Webb Telescope has reached its hovering orbit.
In the coming years, the universe is set to witness a cosmic spectacle unlike anything we've seen before. Scientists suggest that the eventual explosion of Betelgeuse could send ripples of energy across space, challenging our very understanding of the cosmos. Could this future supernova impact Earth in unimaginable ways? How might this cosmic event redefine everything we know about time and space? Renowned astronomers have been discussing a groundbreaking possibility. Betelgeuse, the red supergiant star, is approaching the end of its colossal life cycle. This extraordinary event, which could occur within the next 100,000 years, is poised to captivate the world whenever it happens. The anticipated explosion, known as a Type II supernova, is not only a rare cosmic spectacle, but also a crucial moment for advancing our understanding of the universe. What groundbreaking discoveries could emerge from studying Betelgeuse's dramatic demise? Could this supernova reveal secrets about the life cycles of stars and the evolution of galaxies? Betelgeuse, one of the brightest stars in the Orion constellation, is no ordinary celestial body. If this cosmic giant were to replace our Sun, its immense size would extend all the way to Mars. Situated about 642 light-years away, the light we're seeing from it now actually started its journey during the medieval era. As it prepares for its grand finale, what impact will this fiery event have on what we know about the universe? A star's life is a tale of creation and destruction, starting in dense clouds of gas and dust before fusing hydrogen and helium in its core. When stars like Betelgeuse run out of fuel, they don't quietly fade away. They explode. The bigger the star, the more powerful the explosion. This forthcoming Type II supernova will scatter elements like gold and silver across the universe. The very elements that make up life on Earth were born from ancient stellar explosions like this. Now, why is this potential supernova such a big deal for modern astronomy? It's not just because we're going to see an amazing light show in the sky. It's also because scientists will get a rare chance to study a supernova relatively close to Earth. These events don't happen often, and they're usually really far away. But with Betelgeuse, we'll be able to observe the explosion up close, like having front-row seats to the greatest cosmic show. Scientists will analyze every detail: the shock wave, the energy bursts, and how light reacts. This could completely change how we understand stars, their life cycles, and even how galaxies are shaped. What new knowledge will this explosion reveal? Could it challenge long-standing theories about how stars evolve and the role they play in shaping galaxies? And here's where it gets really exciting. You won't need a telescope to see this. When Betelgeuse eventually explodes, it'll light up the night sky like nothing you've ever seen. It'll outshine every star and may even be as bright as the moon. Whether you're a professional astronomer or just someone who likes to stargaze, you'll be able to witness this incredible event with your own eyes. This isn't just another space event. It's a once-in-a-lifetime experience that will leave everyone in awe. But it's not just about the light show. The explosion will also provide scientists with data that could fuel research for years, maybe even decades. From measuring cosmic distances more accurately to understanding how light and energy behave in space, Betelgeuse's supernova could lead to massive breakthroughs in astronomy. Could we finally uncover some of the universe's deepest secrets? Now, here's an interesting twist. Betelgeuse's explosion won't just be fun to watch. It could also have some effects here on Earth. The energy released might interact with our atmosphere in ways we haven't seen before. It could enhance auroras, those beautiful light shows in the sky that are usually visible near the poles. But this time, they could stretch far beyond their normal range. What other surprises might this explosion have in store for our planet? Could this cosmic event reveal even more about how connected we are to the universe? As we anticipate witnessing one of the most significant astronomical events in modern history, the questions are endless. Betelgeuse's eventual supernova promises not just a spectacle, but an unparalleled opportunity to advance our understanding of the cosmos. What new knowledge will emerge from studying this rare event? How will it shape our understanding of stars, galaxies, and the very building blocks of life itself? Exploring the mysteries of stellar evolution. The future supernova of Betelgeuse will undoubtedly capture the public's imagination, sparking a renewed interest in astronomy and our place in the universe. This event will remind us how stars, like everything else in space, are constantly changing. When Betelgeuse vanishes from the night sky, it will symbolize the natural life cycle of stars and the powerful forces that shape the cosmos. Betelgeuse's explosion will be visible to the naked eye, bringing together professional astronomers and space enthusiasts alike. This rare event will have the whole world looking up, and people from every corner of the globe will work together to capture it from every possible angle. It's not just about advancing science, it's about fostering a shared global passion for the mysteries of the universe. The sheer force of Betelgeuse's explosion is hard to wrap our heads around, but it's a powerful reminder of the immense forces at play in the universe. It illustrates the cycle of creation and destruction that governs the cosmos and prompts us to reflect on our place within it. As we witness the colossal forces of Betelgeuse's explosion, what revelations about our universe will emerge? Will this cosmic spectacle reignite our quest to explore the unknown depths of space? This event could spark fresh debates about space exploration and even the search for life beyond Earth as we keep seeking answers to the biggest questions about our existence. Mark your calendars. Even though we can't predict exactly when it will happen, this supernova is going to be one for the history books whenever it does occur. Thanks to its proximity to Earth and the cutting-edge technology we have today, scientists will be able to observe and analyze it in ways we've never done before. Betelgeuse's explosion is more than just an incredible light show. It's a major milestone in our quest to understand the universe. The data we gather could fuel new discoveries and give us a deeper appreciation of just how dynamic and unpredictable space really is. Betelgeuse's explosion isn't just a stunning visual event. It's a golden opportunity for scientists to dive deep into the mysteries of stellar evolution. What if this supernova holds the key to understanding the life cycles of stars? As the core of Betelgeuse collapses, the data captured could provide an unprecedented look into the heart of these massive explosions. Insights usually hidden behind clouds of cosmic dust and gas. This could change everything we know about how stars live, die, and shape the universe. One of the most fascinating aspects of Betelgeuse's explosion is the potential for extensive neutrino detection. Neutrinos, elusive subatomic particles, are emitted in vast quantities during a supernova. These particles will reach Earth before the explosion's light, giving scientists a critical early warning. Neutrino detectors around the world will be key in gathering this data, allowing researchers to study the supernova's core collapse in real time and provide invaluable information about the processes occurring in the star's final moments. As Betelgeuse blows apart, it'll also collide with the gas and dust it's been shedding for thousands of years. Studying this interaction will give scientists a deeper understanding of the star's life story and the environment it's been living in. This will help piece together the puzzle of how massive stars like Betelgeuse evolve, die, and affect the space around them. This is where it gets exciting. But beyond the science, Betelgeuse's supernova will likely inspire millions of people worldwide. Its dazzling light show will draw people to the night sky, igniting a passion for space and astronomy that could last a lifetime. What new mysteries will this supernova uncover? How many future explorers and scientists will be inspired by this once-in-a-lifetime event to look deeper into the wonders of the cosmos? Betelgeuse's brightness won't just be for scientists. It will catch the eyes of the public too. This incredible celestial event will get people talking, looking up, and wondering about the universe. For many, it will be the spark that ignites a love of astronomy. With modern technology, everyone can get involved, from those with advanced telescopes to those with just a camera phone. This event will truly be for everyone, offering a rare chance to share in the joy of discovery. Will the spectacle of Betelgeuse's explosion spark a cosmic awakening, turning viewers into astronomy enthusiasts, eager to uncover the mysteries of the universe? The broader implications of a supernova. Space-based observatories like Hubble and the James Webb Space Telescope are set to play a huge role in capturing data that telescopes on the ground simply can't. Could this data change the way we look at stellar explosions forever? These powerful tools will give us a clearer, more detailed view of the supernova and its aftermath, helping scientists understand what's really going on in these massive cosmic events. But that's not all. This is just the tip of the iceberg. The impact of Betelgeuse's explosion goes beyond just learning about stars. It could actually help us figure out how supernovae affect nearby planets, which is super important in the search for extraterrestrial life. By studying how these explosions impact other worlds, we might discover what conditions are necessary for life to survive and thrive in different parts of the universe. Culturally and philosophically, the explosion will prompt deep reflection on humanity's place in the cosmos. The transient nature of Betelgeuse and its dramatic end will serve as a powerful reminder of the fleeting nature and interconnectedness of all things. Could Betelgeuse's supernova be the cosmic event that finally reveals the secrets of gravitational waves? What groundbreaking discoveries might we uncover about the universe's fundamental physics through this spectacular explosion? The explosion might trigger detectable gravitational waves, ripples in space-time that provide new data on the star's internal structure. Observing these waves will enhance our understanding of the physics governing supernovae and contribute to the broader field of gravitational wave astronomy. Betelgeuse's supernova could also shed light on the mysteries of dark matter and dark energy. These enigmatic forces make up a significant portion of the universe, yet remain poorly understood. The supernova's energy and light could potentially interact with dark matter and energy in observable ways, offering scientists a rare opportunity to study these elusive components of the cosmos. Now, what if the key to humanity's survival in space lies in understanding the violent deaths of stars? As we dream of colonizing new worlds, how crucial will this knowledge be? Knowing how supernovae work could be vital. We'll need to understand how these massive explosions could affect future space colonies and how to protect ourselves from their cosmic radiation. Betelgeuse's explosion also has big implications for our safety in space. Stars live and die through extreme processes, and each phase can impact future civilizations in space. We need to figure out how to protect our space stations and habitats from high-energy cosmic events. Could observing this supernova inspire new, game-changing technology that will help us survive and explore the far reaches of space? Cultural, philosophical, and technological impacts of Betelgeuse's supernova. Betelgeuse's explosion is not just an astronomical spectacle. It's set to spark a wave of technological advancements, especially in space systems designed to shield us from cosmic radiation. What groundbreaking innovations will emerge from this celestial event? Once Betelgeuse goes supernova, it will unleash an enormous burst of energy into nearby space. Scientists will be eager to capture and analyze this event, which might lead to the development of better systems for monitoring cosmic radiation. These advancements are crucial for long-duration space missions. Could the secrets unlocked by Betelgeuse's explosion be the key to our future in space? Astronauts traveling to Mars or beyond will require sophisticated radiation shielding to protect them from harsh conditions outside Earth's magnetic field. The data collected from Betelgeuse's explosion could help scientists invent new materials and technologies, enhancing the safety of spacecraft, satellites, and space habitats. How will these advancements redefine our approach to space exploration and safety? This explosion could mark a critical turning point for ensuring that humans can explore space safely. As we push the boundaries of our cosmic frontier, are we prepared for the challenges ahead? Ensuring the safety of our astronauts will be more important than ever. But the impact of Betelgeuse's supernova isn't limited to technology. This is more than just science. It's a cosmic wake-up call. It will profoundly affect our cultural and philosophical perspectives, altering how we perceive time, space, and our place in the cosmos. What new philosophies will emerge from witnessing such an awe-inspiring event? This event will challenge our understanding of cosmic timescales, prompting deep reflections on the fleeting nature of existence. Witnessing such a dramatic celestial event can provoke profound philosophical questions about life's impermanence and the vast, ever-changing universe we inhabit. Is astronomy about to become the next big thing? This supernova is likely to spark a wave of artistic and literary creativity. themes of destruction, rebirth, and the unknown inherent in such a cosmic event will provide rich material for artists, writers, and filmmakers. The spectacular visuals and the deep implications of Betelgeuse's explosion can lead to new works of art, literature, and speculative fiction, each exploring universal themes in unique and compelling ways. This explosion will serve as a source of inspiration for stories that examine our fears, hopes, and dreams about the universe. How might Betelgeuse's supernova ignite a passion for astronomy among those who have never looked through a telescope? This explosion will serve as a powerful tool to engage the public with science. It offers a unique chance to educate people about stellar evolution and the life cycles of stars. The visibility of this event to the naked eye will democratize astronomy, allowing astronomers and curious minds to contribute valuable observations. This collective engagement will foster greater appreciation for the scientific process and inspire the next generation of scientists and technologists. Of course, Betelgeuse's explosion will also present significant technological challenges. Capturing and analyzing the immense amount of data generated by this supernova will push the limits of current technology, driving innovations in data storage, processing power, and algorithm development. The insights gained from this event could lead to breakthroughs that benefit not just astronomy, but a variety of scientific and industrial fields. And here's the big picture. A new era of space habitation might be on the horizon. Could this supernova lead to a whole new approach to long-term space habitation? The explosion will likely speed up the development of space infrastructure. Understanding the hazards posed by cosmic radiation is crucial for designing spacecraft and habitats for future missions. The knowledge gained from observing Betelgeuse's explosion will be instrumental in constructing safer, more resilient space habitats, ensuring that human explorers are well protected from the harsh conditions of outer space. What if we discover hidden gems in our galaxy? What if Betelgeuse's explosion reveals clues about habitable planets that may have been overlooked? Studying supernovae like Betelgeuse's is vital in the search for extraterrestrial life. By understanding how these cosmic events impact planetary systems, we can improve our strategies for identifying planets that could support life. This knowledge enhances our understanding of the conditions necessary for life to thrive elsewhere in the universe and boosts our chances of discovering alien civilizations. How does the explosive death of a star contribute to the birth of new worlds? Betelgeuse's supernova illustrates the interconnectedness of the universe. When this massive star explodes, it will eject enormous amounts of material into space, playing a vital role in the creation of new stars, planets, and potentially even life. This cosmic recycling process, where dying stars give birth to new celestial objects, emphasizes that everything in the universe is connected. The elements produced in supernovae, like carbon, iron, and oxygen, are the very building blocks of life, including life on Earth. This event serves as a vivid reminder of the ongoing cycle of creation and destruction that governs the cosmos, emphasizing the intricate web of connections linking all celestial objects. On a social level, Betelgeuse's supernova has the potential to act as a unifying force for humanity. As people across the globe witness this stunning phenomenon, there's an opportunity for a shared sense of wonder and connection. This collective experience can foster global unity, reminding us that we all share the same universe, bound together by our observations and experiences of the cosmos. Might this celestial event inspire a new wave of international collaboration in science and exploration? What if our fascination with the universe brings us closer together in unexpected ways? In the grand scheme of the cosmos, Betelgeuse's explosion will be a spectacle of unparalleled significance. From ensuring the safety of future space travelers to inspiring cultural and philosophical reflections, driving technological innovations, and fostering global unity. This supernova promises to be a landmark event in human history. As we stand on the brink of witnessing this extraordinary spectacle, we are reminded of the vast, dynamic, and interconnected nature of the universe and our place within it. The possibilities are endless, and the excitement is palpable as we anticipate the magnificent show Betelgeuse is bound to put on. Betelgeuse's supernova stands as a testament to the beauty and complexity of the universe. As we gear up for this cosmic spectacle, Embracing the excitement, curiosity, and wonder that it brings is essential. After all, the universe has so many secrets to share, and we are all eager to learn what lies beyond the stars. Will this supernova unlock new cosmic mysteries or pose unforeseen dangers? Share your insights in the comments. Don't forget to like and subscribe for more breathtaking cosmic updates. Until next time, keep gazing at the stars.
Physicists have waited 100 years since 1916 for this photograph.
Due to extensive research over the past few decades, we've transitioned from knowing absolutely nothing about black holes to learning more about them up close and personal. And now things have become even more astonishing. Michio Kaku has just announced that we've finally glimpsed what's inside a black hole. This groundbreaking information sheds light on details that the scientific community might have missed all along. Join us as we delve deeper into black holes and unveil what's inside space's big enigma. Before we dive into the specifics of what Michio Kaku discovered about black holes, we need to discuss the basics. Even though many of us have some understanding of what black holes are, there are still significant gaps in accurate information. In 1916, Albert Einstein published his theory of general relativity, which predicted the existence of black holes. At that time, the concept was purely theoretical. It took another 50 years for the scientific community to find evidence that black holes actually exist. In the 1960s, astronomers studying the Cygnus constellation noticed an unusually bright blue star emitting X-rays. This star wasn't stationary. It was orbiting a massive unseen object. Further investigation revealed that the X-rays weren't just moving independently, but were being sucked into this invisible entity around which they orbited. This led to the term black hole. This discovery was significant because it provided proof that black holes are real and not just figments of Einstein's imagination. While this was an exciting development, it also meant that there was an unknown and potentially dangerous entity in space that we urgently needed to understand better. Scientists worldwide began intensive research. The black hole was named Cygnus X1 and is located in the Cygnus constellation, about 6,000 light-years from Earth. This was no minor discovery. It's about 14 times brighter than the Sun and incredibly dense, resulting in a strong gravitational pull. The gravity is so intense that not even light can escape, hence the term black hole. The concept of a black hole is both fascinating and terrifying. A region in space where gravity is so strong that nothing, not even light, can escape. Anything that gets too close is pulled in, never to be seen again. This inherent danger makes it even more crucial to learn everything we can about them. Was this the end of our journey, or were we just at the beginning? The answer turned out to be the latter. Following the discovery of Cygnus X1, scientists began searching for other black holes. They found that there might be over 100 million black holes in the Milky Way galaxy alone. However, because they are incredibly difficult to detect, we still don't have an exact number. Nevertheless, it's evident that there are several million black holes in our own galaxy, which makes studying them even more important. Let's break it down. The primary concern with black holes is gravity. Their gravitational pull is so intense that anything entering them is compressed astronomically until it becomes a singularity. In simpler terms, black holes act like cosmic vacuum cleaners, sucking in everything nearby. One of the most alarming aspects of black hole research is that if someone were to fall into one, they would be stretched to such an extreme that they become a single line of atoms. This process, known as spaghettification, would happen slowly, and the person would die before reaching their final form. Needless to say, no one should be venturing into one. But given their abundance, could we be in danger? Despite the closest black hole to Earth being about 1,500 light-years away, it's still close enough to raise questions and concerns. In 2021, scientists were able to release the first clear photograph of a black hole, specifically the M87 black hole. This black hole was photographed over several nights, and with each image, researchers gathered more and more evidence. They had to stitch individual photos together to fill in the gaps, which allowed them to determine that black holes consist of 3 layers. They aren't just simple voids as many people believe. To even reach the nothingness at the center of a black hole, you have to pass through the first 2 layers. The first layer is called the event horizon. It's the point of no return. Once you cross it, there's no turning back, and you will be sucked into the black hole. The situation only worsens from there. The second layer is the photon sphere, where light itself orbits the black hole. Any light entering this region becomes trapped and cannot escape the gravitational pull. Finally, we reach the third layer, the singularity. This is where everything entering the black hole is compressed infinitely until it becomes a singularity. The singularity is a point in space-time where the laws of physics as we know them break down, and we cannot predict what happens next. At this point, the density is infinite, and our understanding of physics ceases to apply. What makes this even more complicated is that every black hole is entirely different from the last. While they generally follow the same three-layer concept, their behaviors can vary greatly. If this were any other astronomical phenomenon, we could simply use telescopes to study it in detail. However, with black holes, direct observation isn't feasible. Scientists can only study them indirectly by observing the radiation they emit and the gas and dust that surround them. Sending a probe like Voyager into a black hole isn't possible because anything crossing the event horizon is pulled toward the singularity and compressed into an infinitely small point. You can't justify spending billions of dollars on probes that will be destroyed before providing any data. Because of this limitation, scientists are forced to study these objects in a two-dimensional way, even though they are three-dimensional phenomena. To make matters more challenging, each black hole's uniqueness and the breakdown of physical laws within them mean that traditional scientific methods don't fully apply. Despite these challenges, researchers have been busy formulating various theories and explanations about black holes, each more intriguing than the last. One of the most compelling theories about the formation of black holes is that they are created from collapsed stars. When a star exhausts all its fuel, it can no longer produce enough energy to counteract gravity's inward pull. As a result, the star begins to collapse in on itself, becoming smaller and denser. If the star is massive enough, this process can continue until it becomes a singularity. To understand black holes more deeply, NASA scientists turned their attention to the core of the galaxy, M87. Astronomers observed a super-powerful whirlpool of extremely hot hydrogen gas, spinning at an astonishing rate of 1.2 million miles per hour. The sheer force of this spinning disk should have caused it to fly apart violently in all directions, but it didn't. Scientists deduced that a colossal mass must be concentrated at the galaxy's center to prevent this from happening. This massive object, weighing as much as 2 to 3 billion suns, could only be a black hole. But that's not the only theory involving spinning black holes. In 1963, New Zealand mathematician Roy Kerr used Einstein's equations of gravity to provide the best description of a spinning black hole. Kerr showed that a spinning black hole wouldn't collapse into a single point, but into a ring of fire or a thin disk. This disk spins so rapidly that centrifugal forces prevent it from collapsing. This spinning disk of matter is called the ergosphere, the region surrounding the black hole where the laws of physics start to break down. The most intriguing feature of Kerr's solution was that it predicted the existence of an Einstein-Rosen bridge, also known as a wormhole. This is a theoretical passage through space-time that connects two separate regions of the universe, or even two parallel universes. The idea is that if one were to fall into a black hole, instead of being crushed into oblivion, one might be sucked through a tunnel and shot out of a white hole in a parallel universe. To grasp how this works, we need to consider the concept of space-time. In Einstein's theory, space and time are not separate entities but are interconnected, forming a four-dimensional fabric known as space-time. Objects with mass distort this fabric, creating a gravitational field that causes other objects to move toward them. Imagine a sheet of paper representing space-time. If you place 2 points on the paper and draw a line between them, this represents how objects move through space-time. But what if you could fold the paper in half and create a shortcut between the 2 points? This is the basic idea behind a wormhole, a shortcut through space-time that connects two distant points instantly. Wormholes aren't just science fiction. They are actual predictions of general relativity, although none have been observed directly. The reason is that wormholes are inherently unstable and would collapse almost immediately. But the existence of an Einstein-Rosen bridge would mean that black holes might not just be cosmic vacuum cleaners, but could also be portals to other regions of space-time. So, could we use a wormhole to travel through space and time? Unfortunately, the answer is probably no. Not yet, anyway. Even if we could stabilize a wormhole, it's unlikely we could use it to travel faster than light. Einstein's theory of special relativity predicts that the speed of light is the absolute limit for how fast anything can travel through space-time. Nevertheless, the theory of wormholes and black holes as pathways to other parts of the universe, or even different times, has been a subject of fascination and speculation among physicists for decades. The idea that there might be shortcuts through the fabric of space-time, allowing travel through great distances or even into the past, could be revolutionary if we could actually achieve it. One of the most intriguing concepts in this area of study is the Kerr wormhole, named after Roy Kerr. This type of wormhole is essentially a hypothetical tunnel through space-time that could connect two distant points, such as two different universes or even two different times within the same universe. The Kerr wormhole is often visualized as a ring-shaped portal, similar to the looking glass in the story of Alice in Wonderland. Walking through the looking glass transported Alice to a world where animals spoke in riddles and logic didn't always apply. In the same way, passing through the Kerr ring could potentially transport a traveler to another universe or another time, where the laws of physics might be very different from those we are familiar with. But at the destination, that could be considered normal. While the idea of wormholes as a means of interstellar travel or time travel is certainly exciting, it's also a subject of controversy and debate among physicists. Some have pointed out that wormholes, and particularly Kerr wormholes, might be unstable or impossible to traverse due to the intense radiation and subatomic forces surrounding their entrances. Critics argue that Einstein's equations of gravity, which are used to describe wormholes and black holes, only work for gravity and not the quantum forces that govern radiation and subatomic particles. To truly understand the nature of these phenomena, a new theory is needed that can unite the laws of gravity with the quantum theory of radiation. In the scientific community, this is called a theory of everything, a single theory that can unite both Einstein's theory of gravity and quantum theory. Michio Kaku, a renowned theoretical physicist, has been working on a theory of everything for decades. Among the various versions of what this could be, the one that has shown the most promise is superstring theory. Superstring theory unites gravity with the theory of radiation by proposing that subatomic particles are actually tiny vibrating strings and that the universe is a symphony of these strings. Just as different musical notes correspond to different vibrations of a violin string, different particles in nature correspond to different vibrations of a superstring. One of the fascinating things about superstring theory is that as a string moves in time, it warps the fabric of space around it, producing black holes, wormholes, and other exotic solutions to Einstein's equations. This means that superstring theory not only unites Einstein's theory of gravity with quantum theory, but also explains many of the mysterious phenomena that we observe in the universe. However, there's something about this theory that complicates how simple it might sound at first, but in a way makes more sense too. Superstring theory requires 10 dimensions of space-time in which the strings can vibrate. This is quite different from the 3 dimensions of space and 1 dimension of time that we experience in our everyday lives. It's difficult to imagine what these extra dimensions might be like, but physicists have developed some conceptual models to help us understand. Consider a 2-dimensional pond inhabited by fish that are only aware of length and width. To these fish, there is no such thing as height, and they can't even imagine what it might be like to live in a 3-dimensional world. But if rain falls on the pond and causes ripples, the fish can see the effects of the 3rd dimension even if they can't actually experience it directly. Similarly, physicists believe that we can't see the extra dimensions of space-time directly, but we can observe their effects on the world that we experience. In particular, the vibrations of the strings in superstring theory can produce waves of energy that travel through the extra dimensions of space-time. These waves can manifest themselves as particles with different properties, such as mass and charge. In this way, superstring theory can potentially explain all of the particles and forces that we observe in the universe, including gravity. But there is a catch. The extra dimensions of spacetime that superstring theory requires are so small that we can't really study them directly. The most precise measurements that we can make in our laboratories only use the 4 dimensions of spacetime that we are familiar with: length, width, depth, and time. So how can we even know that the extra dimensions exist? One possibility is that the extra dimensions are curled up so tightly that they are invisible to us. Imagine a sheet of paper that has been tightly rolled up into a cylinder. If you were an ant walking along the surface of the paper, you might not even notice that the paper is curved. Similarly, the extra dimensions of spacetime in superstring theory could be curled up into tiny loops or spirals that are invisible to us, even though they affect the behavior of the strings that vibrate in them. Another possibility is that the extra dimensions were more visible at the beginning of the universe during the Big Bang. According to some versions of superstring theory, the universe began in a state of 10-dimensional spacetime with all of the dimensions equally visible. As the universe expanded and cooled, the extra dimensions began to collapse and curl up, leaving us with the 4 dimensions that we observe today. If this scenario is correct, then we might be able to detect traces of the extra dimensions around us. The mathematics involved in superstring theory is incredibly complex. It's opened up entirely new areas of mathematics that were previously unexplored. However, the challenge of solving the problem of a quantum black hole has proven to be elusive. While many physicists have tried to tackle this problem, no one has yet been able to do so fully. Edward Witten of the Institute for Advanced Study at Princeton has called superstring theory 21st century physics that fell accidentally into the 20th century. Recently, several groups of physicists independently announced a significant breakthrough. They found that string theory could completely solve the problem of a quantum black hole, although only in 2 dimensions, not 10. Many physicists believe that it's only a matter of time before someone cracks this problem, given that the equations involved are well-defined, if difficult to solve. Until then, it's still too early to buy tickets for intergalactic travel or time-traveling expeditions, at least when it comes to black holes. With all of this, one thing is clear. There are simply too many questions and even more solutions to these problems. Michio Kaku has explained how one might determine the real answer among all the theories. He said that it's important to note that the problem of infinite answers isn't unique to string theory. In fact, many great theories have an infinite number of solutions. For example, Newton's laws can predict the motion of various objects, from rocks to rocket ships. But you need to specify what it is you're trying to explain before you can predict its motion. These specifications are called initial conditions. Similarly, in string theory, you need to tell the theory what it's describing. But unlike other theories, the initial conditions of string theory are the Big Bang itself. This means that you have to specify the conditions of the Big Bang at the instant it was created, which are currently unknown. There are a couple of ways to approach this problem. One possibility is to experimentally find the initial conditions at the instant of the Big Bang and then let string theory describe how the universe evolves from there. There are already solutions of string theory that describe the evolution of our universe since the Big Bang, based on some reasonable estimates of its nature. This is a significant achievement. Another more ambitious path is to demand that string theory selects its own initial conditions. That approach is a little more complicated and less likely too. So in a way, we've already narrowed things down significantly. But here, Michio Kaku offers another perspective. Maybe the Big Bang wasn't really all that big, after all. He says it wasn't a massive explosion, as many might think. It also didn't make a loud noise like one might expect from a bang. The Big Bang theory doesn't provide an explanation for what caused the supposed bang or how it occurred. It simply states that it did happen. The truth is, we need a theory that can account for what happened before the Big Bang. This is where string theory comes in. According to this theory, our universe might have been formed from the collision of 2 separate universes, or it could have emerged from another universe, like a baby being born from its mother. This connection between universes is called a wormhole, which is like a tube connecting 2 bubbles. It's possible that we may have already discovered evidence of this umbilical cord that connected our universe to another. In a way, we could just be living inside a black hole this whole time but not know it. Think about it. Because we exist in 4 dimensions and can't see anything beyond them, It's possible that we're actually in a black hole, and the black holes we're studying are actually wormholes to these other dimensions. Do you think there could be truth to that theory? Let us know in the comments below. If you like this video, please give it a thumbs up, and we'll see you in the next one.
NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
The telescope itself has to be extremely cold.
NASA's James Webb Space Telescope, humanity's most advanced observatory, has scarcely begun its journey of cosmic exploration, and already the universe appears more enigmatic and breathtaking than we ever imagined. Scientists have recently uncovered a colossal ring-shaped structure in space, so immense that it challenges our understanding of cosmic formation. Yet just as we stood on the brink of groundbreaking discoveries, an unsettling event has cast a shadow over the telescope's achievements. During an ambitious observational campaign targeting Proxima B, a potentially habitable exoplanet orbiting our closest stellar neighbor, the James Webb Space Telescope mysteriously went dark. This sudden loss of communication has left scientists and engineers scrambling for answers. The telescope's abrupt silence raises concerns not only about the fate of this billion-dollar instrument, but also about what it might have discovered before going offline. Proxima B, situated just over 4 light-years away in the Proxima Centauri system, has long captivated astronomers. As an exoplanet residing within its star's habitable zone, it presents the tantalizing possibility of liquid water, and, by extension, life on its surface. Equipped with unparalleled capabilities to detect the faintest signals across multiple wavelengths, the James Webb Space Telescope aimed to probe Proxima B's atmosphere in unprecedented detail. The goal was to search for biosignatures, geological activity, or any phenomena that could indicate the presence of life or a unique planetary environment. The observational campaign began with high hopes and considerable public interest. Initial data hinted at anomalies in the planet's atmospheric composition, sparking excitement within the scientific community. The telescope registered peculiar spectral lines that didn't match any known chemical compounds typically found in exoplanetary atmospheres. Scientists eagerly awaited further data to decipher these anomalies, speculating on explanations that range from novel chemical processes to the possibility of artificial structures. However, before a clear understanding could emerge, the telescope abruptly lost contact with mission control. The communication blackout occurred during a high-priority transmission window when crucial data was being relayed back to Earth. The sudden silence left operators bewildered. All systems had been functioning optimally moments before. Ground-based teams immediately initiated diagnostic procedures to determine the cause of the loss, but no definitive explanation surfaced. The telescope's systems appeared intact, and there were no signs of technical malfunction. This silence created a void quickly filled with speculation, not only about the technical nature of the failure, but also about the data the telescope might have collected on Proxima B. The implications are profound. It's not merely the loss of a vital piece of equipment, but the fact that it happened amidst one of the most promising investigations in modern astronomy. The data being collected could have reshaped our understanding of our place in the universe. One leading theory among scientists is that the telescope encountered an unexpected cosmic phenomenon near Proxima B, a natural but powerful event that interfered with its communication systems. Cosmic occurrences like intense solar flares, gamma-ray bursts, or magnetic storms are known risks to space instruments. Proxima Centauri, a red dwarf star, is particularly volatile, frequently emitting powerful solar flares that could impact nearby planets and, potentially, instruments observing them. If the telescope was exposed to a sudden surge of radiation or electromagnetic interference, it might have damaged its systems or disrupted communications. Alternatively, some propose that the shutdown resulted from an anomaly in the telescope's software or onboard systems, triggered by the specific data it was processing. In this scenario, the spectral data from Proxima B might have contained unforeseen patterns that interfered with the telescope's data processing algorithms, causing a cascading failure. While this theory is speculative, it raises questions about whether the data itself, rather than an external cosmic event, contributed to the malfunction. If true, this would prompt inquiries into the nature of the detected signals and what could generate them. More controversially, some suggest the blackout wasn't a coincidence. They propose that an intentional signal or structure on Proxima B somehow disrupted the telescope's systems. While such claims verge on science fiction, they can't be entirely dismissed, given our limited understanding of extraterrestrial environments. In the realm where natural phenomena and potential artificiality blur, the possibility of an unknown force or technology interfering with the telescope becomes a thought-provoking, if unsettling, prospect. Proxima B's very nature adds to the mystery. As one of the closest exoplanets to Earth and a prime candidate for habitability, it's always been viewed as a stepping stone in the search for extraterrestrial life. If signs of advanced technology or artificial structures exist beyond our solar system, Proxima B would be a logical place to find them. The exoplanet's proximity and its location in the habitable zone make it one of the few places where conditions necessary for life might be met. Thus, any unusual signals or structures found there would not only be unprecedented, but could have profound implications for our understanding of the universe. The possibility of finding evidence of life or extraterrestrial technology on Proxima B is a notion that has captured human imagination for decades. With powerful telescopes like the James Webb, we finally possess the means to investigate these ideas in detail. However, the thought that the telescope may have encountered something so strange that it disrupted its operations invites more questions than answers. What if the telescope had indeed captured definitive evidence of something beyond our understanding? What if the data it was collecting hinted at a form of life or a structure that defied current scientific paradigms? Such an event would not only be groundbreaking, but potentially paradigm-shifting, challenging our assumptions about life, intelligence, and technology in the cosmos. The scientific implications extend beyond biology and planetary science. If the anomalies detected in Proxima B's atmosphere were caused by biological processes, they could reveal unknown mechanisms of life existing under conditions different from Earth's. Alternatively, if they resulted from non-biological processes, they might point to new geological or chemical phenomena yet to be understood. These findings could force a reassessment of how we define habitable zones, potentially broadening the search for life to include more extreme environments around other stars. Should it turn out that the telescope detected some form of artificial structure or signal, the implications would be even more staggering. Humanity's place in the cosmos would have to be re-evaluated, as the discovery of extraterrestrial technology would indicate that intelligence may not be unique to Earth. Such a revelation would challenge what we consider civilization and might lead to a re-evaluation of technologies and sciences we believe are the pinnacle of human achievement. However, the prospect of such discoveries remains hypothetical. The actual cause behind the telescope's blackout is still unknown, and it's possible it was merely a coincidental technical failure unrelated to the data being collected. Yet the timing invites deeper contemplation. It challenges scientists to confront the limits of current technology and raises questions about what could happen if humanity were to encounter evidence of extraterrestrial life or advanced technology in a direct and unambiguous manner. Would our current scientific paradigms be equipped to handle such a discovery, or would it require a complete overhaul of our understanding of reality? In the immediate aftermath of the telescope's sudden silence, there's been renewed interest in establishing more resilient communication systems and redundancy in future space missions. The incident has exposed vulnerabilities in current exploration methodologies, highlighting the need for systems that can function even if primary communication channels are lost. It has also sparked calls for greater collaboration between space agencies, as a collective effort may be required to investigate and interpret such mysterious phenomena. As the investigation into the blackout continues, the incident has reignited public interest in space exploration. It serves as a reminder that despite all technological advancements, the cosmos remains a place full of mysteries and potential surprises. The unknown can be both a source of fear and a wellspring of curiosity. The idea that the universe might harbor life or advanced technology beyond Earth remains a driving force behind humanity's desire to explore. The telescope's mysterious blackout, rather than dissuading further investigation, has deepened the desire to uncover the secrets of Proxima B and similar exoplanets. This incident is not just an isolated technical setback, It's a reminder of the challenges faced when exploring the frontiers of the unknown. Proxima B, while close in cosmic terms, is still far beyond the reach of any crewed mission in the foreseeable future. The information gathered from such a distant target is inherently limited by the tools and methodologies used. We rely on spectral analysis to understand the composition of exoplanetary atmospheres, but this technique can only provide indirect evidence of what might exist on a world many light years away. Spectral anomalies or unusual data patterns can suggest possibilities, but they rarely offer definitive answers. The peculiar signals detected on Proxima B before the blackout exemplify this limitation. They point towards something unusual, but without more data, the nature of that something remains a tantalizing enigma. The questions arising from this incident go beyond technical troubleshooting or astrophysical curiosity. They touch upon philosophical considerations about humanity's readiness to confront evidence of extraterrestrial life, should it be found. If the telescope did capture data hinting at life or technological artifacts on Proxima B, it wouldn't be the first time scientific evidence has forced society to grapple with uncomfortable new realities. The history of science is filled with instances where new discoveries have upended established views, leading to intense debates and paradigm shifts. The discovery of extraterrestrial life, or even evidence suggesting the possibility, would likely be one of the most profound shifts in human history. The mere possibility that advanced life could exist on Proxima B raises intriguing questions about how such life would manifest. Would it resemble Earth-based biology, following the same chemical and molecular principles, or represent something entirely alien to our understanding? The anomalies detected could correspond to life forms that don't conform to our expectations of carbon-based, water-dependent biology. They might utilize alternative biochemistries or inhabit atmospheric layers rather than planetary surfaces. If life on Proxima B follows different biological principles, it could signify that life is a far more versatile and adaptable phenomenon than currently believed. On the other hand, if the data indicates technological signatures, the implications would be even more far-reaching. A technological civilization on Proxima B would suggest that life is abundant in the universe and that intelligence and the development of complex societies are not unique to Earth. It would challenge the Great Filter hypothesis, the idea that certain steps in the evolution of life are exceptionally rare, serving as barriers to the emergence of intelligent species. If artifacts or signals of non-natural origin were detected, it might suggest that the Great Filter lies ahead of us, presenting existential risks that all advanced civilizations must navigate. Should there be indications of technology on Proxima B, new questions arise. How would a civilization on a planet orbiting a red dwarf star with vastly different environmental conditions develop? Proxima Centauri emits only a fraction of the light our sun provides, and the planet is subjected to intense stellar flares. These conditions would shape any potential technological advancements in ways that differ dramatically from human civilization. A civilization on Proxima B might need extraordinary measures for shielding against radiation, possibly leading to unique materials or energy harnessing techniques. Their cultural and technological priorities might revolve around surviving extreme space weather, resulting in innovations we've yet to imagine. The notion that life or technology on Proxima B could influence the telescope's operations through direct interference, intentional or otherwise, enters speculative territory, but can't be dismissed outright given the telescope's sudden loss of communication. Some theories suggest advanced civilizations might manipulate electromagnetic signals or use cloaking technologies that interfere with remote observations. If anomalies were caused by artificial means, it would open a new field focused on recognizing and understanding non-terrestrial technological artifacts. Even if no direct evidence of life or technology emerges, the investigation into the blackout and its implications can lead to valuable scientific and philosophical insights. One such insight relates to the need for caution in interpreting data from exoplanets, particularly those within habitable zones. The search for extraterrestrial life is inherently biased by our understanding of life on Earth, limited to a single biosphere. Researchers must expand their frameworks for detecting and identifying signs of life beyond familiar patterns of carbon-based chemistry, atmospheric oxygen, and liquid water. Anomalies that don't conform to these patterns may hold the key to discovering alternative forms of life, provided scientists are open to exploring unconventional explanations. The blackout incident may also influence future space exploration missions, emphasizing the importance of diversifying observational strategies. As technology advances, telescopes and probes will increasingly need to operate autonomously, employing artificial intelligence to make decisions when communication with Earth is compromised. The loss of the telescope during its observations of Proxima B highlights the need for robust fail-safes and more adaptable systems that can continue to collect data even when contact is lost. This could involve developing new ways to transmit information across greater distances or implementing automated protocols that allow space instruments to prioritize and store data. Moreover, the incident underscores the necessity of multi-mission collaboration. Telescopes like Hubble and future missions, such as the Nancy Grace Roman Space Telescope, could be employed in tandem to cross-check findings, ensuring no single point of failure jeopardizes an entire line of inquiry. Agency cooperation among NASA, ESA, and other international organizations would enhance data sharing capabilities, verifying important discoveries through multiple independent observations. This coordinated approach would improve the resilience of space science, making the search for life beyond Earth less susceptible to the loss of a single instrument. Such a diversified strategy could also foster innovation by encouraging the development of specialized, smaller-scale technologies designed to target specific types of data or phenomena. On a broader scale, the mystery surrounding the telescope's blackout raises questions about the inherent risks of pushing the boundaries of human knowledge. Exploring the unknown involves uncertainty, and setbacks like these remind us of the unpredictable nature of space exploration. Yet it's precisely these risks that make the endeavor worthwhile. The potential rewards, unlocking the secrets of the universe, discovering life beyond Earth, or encountering signs of other civilizations, are too significant to ignore. While the incident represents a setback, it reinforces the importance of resilience and adaptability in scientific exploration. The quest to understand what happened during the telescope's observations of Proxima B will undoubtedly continue, as will the search for habitable worlds and extraterrestrial life. Even if no definitive answers emerge from this incident, the intrigue it has generated will fuel further investigations, drive technological innovation, and inspire a new generation of scientists and explorers. Each challenge faced in space exploration brings lessons that inform the next phase of discovery, bringing humanity closer to answering age-old questions. Are we alone in the universe? And if not, what forms might our cosmic neighbors take? Another technological implication of the mysterious shutdown could be the development of more sophisticated onboard data processing and storage capabilities. With such high stakes in data collection, especially when investigating potential signs of extraterrestrial life, space observatories may need to employ advanced artificial intelligence systems. These systems could autonomously analyze and prioritize data, ensuring that even if communication with Earth is lost, valuable information is preserved. Such capabilities could transform space exploration, allowing missions to adapt dynamically to unforeseen challenges and ensuring that crucial data isn't lost. There's also a renewed call for distributed space telescope arrays. Instead of relying solely on a single large observatory, deploying constellations of smaller specialized telescopes is gaining traction. These arrays could be distributed across various orbits or even positioned at different points throughout the solar system to observe distant objects simultaneously from multiple perspectives. This approach would provide redundancy and a broader observational capacity, enabling simultaneous coverage of different wavelengths or multiple targets. If one instrument goes offline, the remaining components can continue the mission, reducing the risk of catastrophic data loss and enhancing our ability to detect subtle signals that might indicate life or unique planetary processes. The interest sparked by the blackout and its potential connection to Proxima B may also accelerate timelines for more ambitious space missions focused specifically on detecting life. Projects like the Breakthrough Starshot initiative, aiming to send tiny, light-propelled probes to the Alpha Centauri system, could receive increased funding and public support. By sending small, fast spacecraft equipped with cameras and instruments capable of gathering direct data, humanity could achieve unprecedented detail in studying exoplanets like Proxima B. The incident may prompt a re-evaluation of the kinds of exoplanetary signatures scientists prioritize in their search for life. Historically, the focus has been on finding Earth-like conditions, liquid water, a stable atmosphere, and an energy source. However, the strange atmospheric signals detected suggest life could exist in forms or under conditions not yet considered. This could broaden the criteria used to assess habitability, leading scientists to investigate more exotic biosignatures. For instance, certain gases or isotopic ratios that seem unrelated to biological activity might be re-examined for their potential as indirect indicators of life, especially in vastly different atmospheres. Another intriguing avenue is the concept of technosignatures, evidence of technology or industrial activity on other planets. Traditionally, the search for extraterrestrial intelligence has concentrated on detecting radio signals. But this approach may be too narrow. If signals from Proxima B were artificial, they might not manifest as conventional radio waves, but could involve different types of electromagnetic emissions, anomalous heat signatures, or unusual light patterns. This event might push researchers to develop new methods for detecting such signs, utilizing novel algorithms that sift through massive data sets to identify anomalies indicating technological artifacts or advanced life forms. While the investigation continues, the telescope's blackout has influenced how astronomers and astrobiologists think about the fragility and vulnerability of space missions. Future observatories may need better shielding against cosmic radiation and stellar flares, especially when observing volatile star systems. They may also require real-time adaptability to unexpected cosmic events. Adaptive shielding that dynamically responds to environmental changes in space could become standard, helping prevent disruptions by automatically adjusting to sudden spikes in radiation. As discussions about Proxima B's possible significance evolve, the incident prompts deeper theoretical inquiries into the nature of communication in the universe. If there were intentional interference by a higher intelligence, it raises fascinating questions about how different civilizations might communicate across interstellar distances. Would an advanced civilization choose to obscure its presence to avoid detection? Could the anomalies be a form of cosmic camouflage or an attempt to signal in a manner not yet understood by human science? These speculative but compelling questions encourage new paradigms in interstellar communication, broadening the scope beyond conventional radio and light-based signals to include more cryptic or indirect forms of interaction. Moreover, the implications of potentially encountering life or intelligent signals would extend far beyond science. Philosophical, cultural, and even theological considerations would come to the forefront, challenging humanity's understanding of its place in the cosmos. The discovery of life, especially intelligent life, on another planet would prompt profound questions about the uniqueness of human existence. Religions and cultural narratives may have to reconcile with the idea that life exists elsewhere, possibly with different forms of consciousness or societal organization. Such a revelation could unify humanity under a shared identity as Earthlings, fostering a greater sense of global collaboration and responsibility to preserve our planet, knowing that life isn't a solitary phenomenon in the universe. In philosophy, this incident could invigorate discussions about the nature of consciousness and its potential manifestations beyond Earth. If Proxima B hosts life, particularly intelligent life, it could challenge anthropocentric views of intelligence and consciousness. Philosophers and scientists might revisit theories of mind, awareness, and ethics, considering that consciousness could arise under vastly different conditions. The implications could extend to the ethical treatment of hypothetical extraterrestrial life, raising questions about rights, responsibilities, and protocols for contact. The telescope's sudden blackout has also highlighted the psychological aspects of space exploration. The public's response reflects a deep-seated fascination with the search for life beyond Earth and a fear of the unknown. If life or advanced technology were found on Proxima B, it would challenge not only scientific, but also societal perceptions of what it means to be human. The event has stirred imaginations worldwide, fueling excitement and anxiety about the possibility of first contact. This psychological impact could shape public policy, influencing funding for space exploration and guiding international efforts toward collaborative approaches in handling discoveries that could reshape humanity's self-view. The mysterious nature of the blackout, paired with the anomalous data, has led to renewed interest in contingency planning for potentially disruptive space-based discoveries. There's already discussion about forming dedicated task forces or intergovernmental agencies to manage the implications of discovering extraterrestrial life or technology. Such groups would focus not only on scientific analysis, but also on addressing social, political, and economic ramifications. Policies might be crafted to establish protocols for data sharing, public announcements, and careful interpretation of findings to avoid misinformation or panic. Governments and space agencies could consider contact scenarios akin to disaster preparedness plans to ensure readiness for whatever lies out there. While the true cause of the communication failure is yet to be determined, the incident invites reevaluation of how we interpret astronomical data, particularly when dealing with potential extraterrestrial phenomena. It has triggered conversations about the limitations of human cognition in processing novel forms of data. The possibility that our instruments encountered something our current scientific models can't explain highlights the importance of keeping an open mind. This openness must be tempered by rigorous scientific analysis to avoid premature conclusions. The search for life and intelligence in the universe is fraught with uncertainty, and the incident serves as a reminder that while we can make incredible advancements, the cosmos remains a place of mystery where answers aren't always immediate. In the absence of a definitive explanation, the mystery surrounding the telescope's blackout encourages speculative thinking about the universe's nature and our place within it. The questions raised aren't just about what we found or didn't find on Proxima B, but about the limits of our knowledge and the potential for future discoveries that could change human history. It challenges scientists to push beyond conventional boundaries in methods and theories, exploring the fringes of what's considered possible. Each new discovery, each anomaly, brings us one step closer to understanding the vast, complex universe we inhabit. Whether the telescope's silence was due to technical failure, cosmic interference, or something more extraordinary, it has undeniably reignited our collective curiosity and determination to seek answers.
Our theories.
Webb has now found galaxies that we are seeing as they looked when the universe was only about 300 million years old.
If there's any one of these planets that has what we would call a habitable
surprises left out there for us.
As for the penguin and the egg, they'll continue their cosmic dance for another 1 billion years or so before ultimately merging into one galaxy.
President Biden recently unveiled the first publicly displayed image captured by the James Webb Telescope. Meanwhile, the unexplored depths of our oceans harbor mysteries beyond our wildest imaginations. Cryptic remnants of bygone eras, submerged cities, and haunting traces of life linger beneath the waves, awaiting discovery. Yet, amid the allure of unearthing these secrets, there's a subtle sense of unease. What if some of these submerged enigmas were never meant to be uncovered? Join us as we dive deep to reveal 15 underwater discoveries that have left even the most intrepid explorers shaken. Prepare yourself to be both captivated and terrified. The James Webb Space Telescope's launch on Christmas Day in 2021 was nothing short of extraordinary. It ascended into the sky atop a powerful European Ariane 5 rocket, taking off from a launch site nestled in the lush forests of South America, a setting that added a touch of natural grandeur to this monumental event. For 3 decades, thousands of scientists worldwide had dedicated their collective expertise and effort to this project, culminating in this significant achievement. However, such monumental endeavors are fraught with immense risks, and the shadow of possible failure loomed large throughout the process. Astonishingly, everything proceeded with near-perfect precision. The telescope embarked on an arduous journey spanning nearly 1 million miles, enduring 30 days of travel through the vast emptiness of space. Its ultimate destination was the enigmatic Lagrange Point 2, a region in space where gravitational forces achieve a delicate balance, situated opposite the Sun relative to Earth's orbit. This location had already become home to other space observatories like the Herschel Space Telescope and the Planck Space Observatory, making it an ideal vantage point for the James Webb Telescope to commence its cosmic voyage. As the telescope set off on its celestial journey, NASA laid out its ambitious plans, highlighting 4 primary areas of exploration. Foremost among these was the aim to witness the universe's very first burst of light, a pivotal moment in cosmic history. The telescope sought to delve into the ancient celestial past, unraveling the mysterious formation of galaxies during the universe's earliest stages. Beyond this cosmic archaeology, the James Webb Telescope was also poised to reveal spectacular celestial phenomena of immense significance. It aspired to peer into the nurseries where stars are born, shedding light on the origins of stars and the development of protoplanetary systems. Furthermore, its mission extended to exploring the vast array of planets, delving into the grand narrative of planetary existence and the elusive origins of life itself. These scientific frontiers had long resisted comprehensive exploration due to the inherent challenges involved in scrutinizing the universe at such depth. Before it could embark on its observations, the telescope underwent a meticulous series of scientific tests and calibration procedures. One crucial examination involved deploying a remarkable protective shield designed to safeguard its sensitive instruments from the relentless heat and blinding radiance of the sun. Given the telescope's perpetual journey through the cosmic void, this shield was absolutely essential. The sun shield, a massive structure composed of 5 meticulously layered membranes, had been carefully folded in a complex accordion-like fashion. Unfolding it required a precise choreography of steps, each calibrated to ensure proper tension and alignment of every layer. The stakes were incredibly high. Any misalignment or damage to this crucial shield could severely impair the telescope's ability to observe the distant, mysterious realms of the universe. With great relief, the telescope successfully completed this initial test, paving the way for the next critical challenge. The subsequent task was to unfold the telescope itself, a highly delicate procedure. Even though it was already precisely positioned in space, it needed to prepare meticulously to fulfill its cosmic mission. At the heart of the telescope lay its primary mirror, an intricate mosaic of 18 hexagonal segments that required perfect synchronization to capture sharp, detailed images of celestial objects. The preparation was a complex and fragile process, involving not just the deployment of its colossal sun shield, but also the careful extension of its support structures and the gradual unfolding of its primary mirror. However, revealing the mirror was merely the beginning. Every component had to align flawlessly to enable the telescope to achieve its scientific objectives. Another intricate calibration involved activating the telescope's scientific instruments one by one, as if awakening dormant senses. These instruments included the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument, each endowed with unique capabilities for observing the universe and adding layers of intrigue to the mission. Additionally, the telescope needed to establish its orientation in space, a process known as commissioning. This involved studying calibration markers and refining its aim to ensure that its instruments were precisely locked onto their celestial targets. All these rigorous tests served as gatekeepers, ensuring that the telescope was fully prepared to embark on its odyssey and uncover the universe's yet unknown secrets. As these complex procedures unfolded, anticipation swept through the scientific community. Everyone held their breath, hoping for success, while fully aware that, in the realm of science, things often don't go as planned. To the astonishment of all, the telescope passed every test flawlessly, an achievement nothing short of astounding. This monumental project had brought together over 300 universities, organizations, and companies from 29 US states and 14 different countries. Then, in July 2022, after overcoming every challenge presented by NASA, the James Webb Space Telescope received the green light to embark on its remarkable scientific journey. NASA proudly announced that all 17 of the observatory's scientific instrument modes had undergone rigorous scrutiny and were now ready for action. Like any other telescope, its primary purpose is to collect and focus light to reveal distant celestial wonders. However, what sets the James Webb Telescope apart is the specific portion of the electromagnetic spectrum it observes. While human eyes are limited to perceiving visible light, this telescope sees beyond, into a hidden realm of cosmic phenomena. This profound shift in perspective opens new horizons in our quest to understand the universe. The James Webb Space Telescope functions like a cosmic heat detector, akin to a futuristic night vision camera capable of gazing into the depths of the universe on a grand scale. Its enormous size allows it to gather more light than any other telescope, enabling it to observe even the tiniest and most distant celestial wonders. The best part is that it's stationed in space, free from the atmospheric distortions that often blur our terrestrial views, earning it the nickname, the universe's watchful eye. But how does this marvel perform its cosmic magic? At its core is a colossal 21-foot mirror that captures and reflects light back to the telescope's intricate instruments. Speaking of instruments, the telescope is equipped with 4 main devices, each with its unique capabilities. First is the near-infrared camera, the telescope's primary eye, which captures breathtaking images of distant galaxies, nebulae, and other celestial marvels. Next is the near-infrared spectrograph, functioning like a cosmic prism that breaks down light into its component colors to reveal secrets about the objects it observes. Then there's the mid-infrared instrument, specifically designed to collect infrared light. It delves into the mysteries of the early universe, explores exoplanets, and even takes a closer look at our own solar system. Finally, the fine guidance sensor, near-infrared imager, and slitless spectrograph ensure the telescope points in the right direction and are highly sensitive to near-infrared light. Together, these instruments leave no cosmic stone unturned. The true magic lies in understanding the expanding universe. As the universe stretches and grows, light from distant corners gets red-shifted. Its wavelengths become stretched, making it appear redder than it originally was. By observing the universe in this red-shifted light, we can literally look back in time, seeing the universe as it was in its early days. Imagine witnessing the birth of stars and galaxies, learning about the ancient conditions that shaped our cosmos. The telescope's remarkable ability to gaze deep into the universe essentially allows it to peer back in time. The farther an object is from us, the longer its light takes to reach our telescopes. Therefore, when the telescope focuses on a distant galaxy, it's not just capturing a current snapshot, but revealing how that galaxy looked billions of years ago, when its light began its interstellar journey. This unique capability enables scientists to delve into the ancient history of the universe, studying the processes that sculpted the cosmos we observe today. The telescope's capabilities made a grand entrance into the public eye on July 12, 2022, when NASA unveiled its first batch of scientific images during a live event. These pictures were breathtaking. Imagine gazing at the cosmic cliffs within the Carina Nebula, or marveling at the ethereal beauty of the Southern Ring Nebula. These images were more than just visually stunning. They were windows into the vastness of space and time. The telescope didn't stop at aesthetics. It also delved into scientific intricacies. It analyzed the atmospheric composition of the scorching gas giant exoplanet WASP 96b, offering critical insights into alien worlds. Additionally, it presented a captivating view of Stephan's Quintet, a group of galaxies engaged in a mesmerizing celestial dance as they merge and interact. These images sparked excitement not just for their visual splendor, but for the profound scientific revelations they brought. However, it was back in February 2022 that NASA first offered the world a glimpse into the telescope's astounding capabilities. NASA announced the telescope's inaugural glimpse of starlight, a mosaic composed of 18 scattered luminous dots featuring the prominent star HD 84406. Thomas Zurbuchen, NASA's Associate Administrator for the Science Mission Directorate, excitedly tweeted that as the telescope honed its focus, these 18 celestial beacons would seamlessly merge into a single radiant star. This achievement marked a thrilling milestone, illustrating the telescope's immense potential for future discoveries and interstellar explorations. In the weeks that followed, the telescope continued its journey of progress. On February 18th, NASA unveiled an updated image of HD 844006, where the 18 dispersed star images had been carefully arranged into a mesmerizing hexagonal formation. This offered a tantalizing glimpse of the grandeur that awaited once the observatory precisely aligned the individual segments of its primary mirror. This alignment ushered in the era of image stacking, promising to unlock even more cosmic wonders. The telescope even took a daring selfie using a high-tech camera nestled within the near-infrared camera instrument. Initially intended for engineering and calibration tasks, this camera captured a stunning image where one mirror segment outshone the rest, gleaming with radiance born of perfect alignment and unerring focus on a distant star. Gradually, each mirror segment fell into place, revealing the telescope's breathtaking precision and unwavering accuracy. The real showstopper came when the telescope directed its gaze deeper into the Eagle Nebula. Towering columns of gas and dust stretched into the boundless universe like colossal sentinels guarding cosmic secrets. The Hubble Space Telescope had previously captured the stunning beauty of these celestial formations, but it could only reveal the surface, leaving the enigmatic secrets within untouched. This is where the James Webb Space Telescope took center stage. Its extraordinary infrared imaging technology penetrated deeper, unraveling the hidden processes occurring within the pillars of creation in the Eagle Nebula. In the telescope's latest image, a mesmerizing scene unfolds. Countless protostars emerge like crimson pinpricks against the smoky backdrop of the towering pillars. These massive collections of dust and gas, each dwarfing our entire solar system, serve as cosmic cradles for newborn stars. Captured in their infancy, these stars have not yet ignited hydrogen fusion. According to Derek Ward Thompson, head of the School of Natural Sciences at the University of Central Lancashire in the UK, they patiently accumulate material over time, becoming denser at their cores. Suddenly, a transformative moment occurs when hydrogen ignition sparks to life, and their temperatures soar to an astonishing 2 million degrees Celsius. The image is a masterpiece, using a vibrant palette of colors to depict the mostly invisible realm of infrared wavelengths. It's a vivid glimpse into the hidden wonders of the universe unveiled by the telescope's extraordinary capabilities. Anil Kokirala, an astronomy researcher at the Space Telescope Science Institute in Baltimore, skillfully assembled this captivating image using data from the telescope. He revealed a fascinating aspect. Although the image appears entirely blue to our eyes, these regions would actually look radiant red without specialized equipment. This phenomenon occurs because, as the wavelengths of radiation increase, the colors shift toward the red end of the spectrum. In this image, the protostars emit radiation with wavelengths roughly 6 times longer than what the human eye can perceive. This intriguing aspect isn't merely about visual aesthetics. It provides valuable insights into the formation of stars, including our own sun. Images like this not only showcase the telescope's prowess as an infrared observatory, but also offer a unique window into the early stages of star formation and its evolution over time. Yet, as mesmerizing as stars are, one enigma remains unresolved: the direct imaging of exoplanets. In the early 1990s, scientists embarked on a journey that would forever change our understanding of the universe. They sought to uncover the secrets of distant stars by discovering exoplanets, celestial bodies orbiting those far-off suns. Using a subtle yet brilliant technique, they monitored the faint dimming of a star's brightness as an exoplanet crossed its path. Fast forward to the present, and a new era is upon us. Following the telescope's successful launch and commissioning, this technological marvel brought unprecedented sensitivity and advanced instruments to the quest. Within just a year of its maiden voyage, the telescope etched its name in the annals of space exploration by directly imaging an exoplanet, HIP 65426b, a colossal gas giant discovered in 2017. The astonishing feat lay in the exoplanet's location, an unimaginable distance, sitting a staggering 100 times farther from its host star than Earth is from the Sun. Achieving this monumental task required the coordinated efforts of the telescope's 2 reliable cameras and a variety of filters. The resulting images were carefully merged to create a composite portrait that left astronomers in awe. The exoplanet's image unveiled its grandeur, a stunning breakthrough that captivated the scientific community. What makes this exoplanet truly stand out is its sheer size. A behemoth among giants, it is approximately 12 times the mass of Jupiter, our solar system's largest planet. The telescope's enormous size and its distance from the host star allowed it to capture these astonishing images with relative ease. Yet, its mission extends beyond creating captivating visuals. Through these images, we gain insights into the intricate processes of planet formation and the diverse atmospheres they possess. Such knowledge fuels hope in our quest to discover exoplanets with environments conducive to life, a pursuit that has spanned decades with limited success. The telescope's unique ability to closely observe planets raises our optimism for future discoveries. The telescope has also successfully observed the most ancient galaxies known to humanity, galaxies that formed when the universe was merely 2% of its current age. These 4 galaxies are the most distant celestial bodies ever observed, residing at an astonishing distance of approximately 13.4 billion light-years from us. Imagine that the light we now see from these galaxies began its journey 13.4 billion years ago, traversing a vast cosmic expanse to finally reach our telescopes. This remarkable achievement allows us to peer back in time, capturing vivid images of these galaxies as they existed over 13 billion years ago. This extraordinary feat was no small undertaking. Scientists faced the daunting challenge of identifying these galaxies, made all the more formidable by their staggering distance. Thanks to the telescope's exceptional infrared capabilities, it managed to detect even the faintest signals from these ancient celestial objects. As part of the advanced Deep Extragalactic Survey, researchers singled out 4 galaxies from the cosmic tapestry. However, identifying them was just the beginning. To confirm their age and unravel the mysteries of their distant past, the research team delved into data collected by the telescope's near-infrared spectrograph. This sophisticated instrument allowed them to decipher the redshift of these galaxies, a crucial piece in understanding the universe's infancy. Recently, researchers have been intrigued by the possibility that the telescope could capture the sharpest images of city lights ever seen, offering views of urban landscapes like never before. While it might seem like a lofty goal, the chances of making this a reality are surprisingly good. Consider Proxima Centauri, the closest star to our Sun, located 4.25 light-years away. In this distant realm, astronomers discovered Proxima B, a planet residing in the star's habitable zone and thought to be tidally locked, with one side perpetually facing its sun and the other in constant darkness. If a technologically advanced civilization exists on Proxima B, they might have covered the daylight side with solar panels to harvest energy, which could then illuminate and warm the planet's dark side. Enter the James Webb Space Telescope, a cutting-edge scientific instrument. In a recent research paper, scientists showcased its potential to detect artificial city lights on the perpetual night side of Proxima B. Even if these city lights were as faint as Earth's nighttime illumination, the telescope could detect them, provided they occupied a frequency band 1,000 times narrower than natural starlight. But the story doesn't end there. Future space telescopes, such as NASA's proposed Large Ultraviolet Optical Infrared Surveyor, promise to be even more sensitive, potentially picking up even fainter traces of artificial illumination on Proxima B's night side. The idea that we might glimpse city lights on a planet over 4 light-years away is truly mind-boggling. It's a powerful reminder of how much there is still to discover in our vast universe. Telescopes like the James Webb Space Telescope bring us one step closer to unraveling the mysteries of our solar system and galaxies far, far away. Thank you for joining us on this journey. While you're still here, make sure to click the video on your screen for more quality content.
Close to the blazing sun, a tiny planet holds monumental secrets. Mercury, the smallest and hottest planet, tricked us for a long time, but today space probes have uncovered strange and unexpected surprises. They even suggest the possibility of diamonds existing on the hottest planet.
Scientists have found that a thick layer of diamonds may exist hundreds of miles beneath Mercury's surface.
And that's only scratching the surface. Mercury's internal structure is unusual, too large, too peculiar. What makes it so different from the other planets? And what other hidden secrets might Mercury still be keeping? Mercury, the smallest planet in our solar system, has captivated the interest of astronomers and space enthusiasts for years. Its enigmatic surface, veiled for centuries, only began to unveil its mysteries with the advancement of space exploration technology. The quest to understand Mercury's bizarre landscape started with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe, which launched in 2004. Mariner 10, the first spacecraft to fly by Mercury, provided us with our initial close-up look at this elusive planet. As it passed by, it captured images revealing a landscape covered in craters and unusual ridges, similar to our moon. This mission showed that Mercury had a rough, cratered exterior, along with an unexpectedly strong magnetic field and a much larger core than scientists anticipated. These discoveries reshaped previous assumptions about Mercury's composition. The Messenger mission, formerly known as Mercury Surface, Space Environment, Geochemistry, and Ranging, was launched 31 years after Mariner 10. It significantly expanded our knowledge of Mercury. Unlike Mariner 10, Messenger was designed to enter Mercury's orbit, allowing for an in-depth study of the planet. Over the course of its mission, Messenger captured an astonishing 200,000 images, revealing never-before-seen regions of Mercury. One of the most fascinating discoveries made by Messenger was the detection of unusually high levels of calcium and magnesium on Mercury's darker side. This sparked questions about what processes could create such unusual concentrations. Additionally, the mission revealed that Mercury's magnetic field was notably stronger in its northern regions, a surprising difference from other planets. These findings led scientists to understand that Mercury's interior structure and formation history were vastly different from what they had previously assumed. On planets like Earth, magnetic fields are created by the movement of liquid iron within the core. However, Mercury's internal makeup produces a unique magnetic behavior. What makes Mercury's surface particularly remarkable, though, isn't just the craters and ridges, but also the extreme surface conditions. By day, temperatures on Mercury can reach a scorching 430 degrees Celsius, 806 degrees Fahrenheit, hot enough to melt lead. At night, however, these temperatures drop to an icy minus 180 degrees Celsius, minus 292 degrees Fahrenheit. These wild temperature swings are due to Mercury's very thin exosphere, which provides little insulation or heat retention. Even in these harsh conditions, researchers have found surprising features on Mercury's surface. In 2012, Messenger data revealed signs of volcanic activity, including pyroclastic deposits from explosive eruptions. This discovery overturned the long-standing belief that Mercury was geologically inactive. Even more remarkable, in 2020, scientists announced the discovery of water ice in Mercury's polar craters. These permanently shadowed regions are so cold that they can preserve water ice, even though Mercury is extremely close to the Sun. This discovery has led to new speculation about the possibility of simple life forms on Mercury. Could extremophiles, like those that exist in extreme conditions on Earth, be living in these icy pockets? The most recent Mercury mission, Bepi Colombo, was launched in 2018 as a collaborative project between the European Space Agency and the Japan Aerospace Exploration Agency. The spacecraft is expected to arrive at Mercury in 2025. This mission promises to deliver even more detailed data about Mercury's surface, including its chemical composition and geological evolution. From its unexpectedly strong magnetic field to the existence of water ice, Mercury continues to astonish scientists. Now, if you thought Mercury's secrets were done, think again. What you're about to learn will completely flip your understanding of time on this planet, a year shorter than a day. When we typically think of planets, we imagine them spinning once on their axis per day and orbiting the Sun once per year. However, Mercury defies this usual pattern in a very intriguing way. On this small sun-baked planet, a single year is actually shorter than a day. Let's explore this peculiar fact. Mercury completes an orbit around the Sun in just 88 Earth days, making its year far shorter than our own. But here's where it gets even more fascinating. One full rotation of Mercury on its axis, a single day, takes an astounding 176 Earth days. This means that on Mercury, a year is only half the length of a day. This odd scenario leads to some truly strange phenomena. If you were standing on Mercury's surface, you would witness the sun rise and grow larger in the sky as it slowly moved. At one point, the sun would appear to stop, move backward for a while, and then resume its usual path. This bizarre movement happens because Mercury's rotation cannot keep pace with its quick orbit. But what causes Mercury's sluggish rotation? Scientists believe the answer lies in a process called tidal locking. Over billions of years, the sun's gravitational pull has gradually slowed Mercury's spin. Unlike our moon, which is entirely tidally locked to Earth, Mercury exhibits a 3-to-2 spin-orbit resonance. This means it rotates 3 times for every 2 orbits around the sun. The extreme nature of Mercury's day-night cycle has intense consequences on its surface. The side facing the sun is scorched by extreme heat for months, while the night side is left in freezing darkness for an equally long time. These extremes contribute to some of the most dramatic temperature swings in the solar system. As for Mercury's atmosphere, or lack thereof, it is worth noting that the planet's extremely thin atmosphere is called an exosphere. This fragile layer is constantly being lost to space and replenished by various processes such as the solar wind, radioactive decay, and impacts from micrometeorites. Surprising new discoveries have recently been made about Mercury's exosphere. In 2020, researchers analyzing data from the Messenger spacecraft revealed that Mercury's exosphere contains more water vapor than previously thought. This water vapor likely forms when hydrogen from the solar wind combines with oxygen in Mercury's rocky surface. Mercury's short year and long day also have fascinating effects on its magnetic field. Despite its small size and slow rotation, Mercury has a global magnetic field, a finding that surprised scientists. New research indicates that Mercury's magnetic field may be created by a unique dynamo effect in its liquid metal core, influenced by its peculiar orbital and rotational dynamics. This magnetic field, although much weaker than Earth's, plays a vital role in shielding Mercury's surface from the relentless solar wind. Without it, the solar wind would erode Mercury's thin exosphere even faster. Additionally, Mercury's rapid orbit and sluggish spin create opportunities for intriguing observations. Specific points on the planet, known as hot poles, experience the most intense heat because the sun appears to linger in the sky there. On the other hand, there are regions near Mercury's poles that never see sunlight. These permanently shadowed areas are where scientists have discovered signs of water ice. How can water ice exist on a planet so close to the sun? The answer lies in Mercury's orbit and rotation. The permanently shadowed craters at its poles remain in constant darkness, keeping temperatures cold enough to preserve the ice even while nearby areas are baked by the sun's heat. This finding leads scientists to ponder whether other volatile substances, perhaps even organic compounds, might also be preserved in these frozen traps. Mercury's short year and lengthy day also impact how we study the planet. Its fast orbit makes it difficult for spacecraft to reach Mercury, requiring complex maneuvers and multiple flybys of Venus and Mercury itself to slow down enough for orbital insertion. The Bepi-Colombo mission, currently en route to Mercury, will rely on these gravitational assists to adjust its speed and trajectory. Although launched in 2018, the spacecraft will not enter Mercury's orbit until 2025, after completing 9 planetary flybys. Once in orbit, Bepi-Colombo will face another hurdle due to Mercury's unusual day-night cycle. The spacecraft must balance exposure to Mercury's intense heat during the day and maintain power through the long, freezing nights. This delicate operation will be critical for the mission's success, demonstrating the extreme conditions created by Mercury's rotation and orbit. Recent simulations have shed light on how Mercury ended up with such a peculiar rotation rate. These studies suggest that Mercury once rotated more quickly, but its spin was gradually slowed down by the sun's gravitational forces and impacts from large comets or asteroids. Understanding Mercury's slow spin helps scientists piece together not only its history, but also the evolution of other planets in our solar system. As researchers continue to explore Mercury, new mysteries emerge. How does Mercury's core stay partly liquid despite the intense cold during its long nights? What role does Mercury's strange orbit play in its geological processes? These questions remind us that even within our own solar system, many puzzles remain unsolved. Mercury's unique characteristics push us to reconsider how planets form and evolve, encouraging new ideas and theories. Just when you think you've wrapped your head around Mercury's bizarre day, the planet throws another curveball. Its secrets are far from over. A small planet with too many intense secrets. Mercury, the tiniest planet in our solar system, manages to hold an astonishing number of mysteries despite its small size. Scientists continue to be intrigued by Mercury as its distinctive features and unexpected discoveries defy initial expectations. One of the most captivating mysteries of Mercury lies in its unusually large core. Dr. Nancy Chabot, a planetary scientist at Johns Hopkins Applied Physics Laboratory, conducted a study revealing that Mercury's core accounts for about 85% of its total volume. This is significantly larger compared to Earth's core, which only takes up about 15% of its volume. But what caused Mercury to have such an enormous core? One theory suggests that Mercury might have once been a much larger planet, but a colossal collision early in the history of the solar system caused it to lose most of its outer layers. This hit-and-run theory was proposed by Dr. Eric Asfog from the University of Arizona, who believes that a planetesimal struck Mercury, stripping away much of its mantle and crust, leaving behind the iron-rich core that we observe today. Mercury's magnetic field presents another puzzling mystery. Unlike Venus and Mars, which lack global magnetic fields, Mercury generates a magnetic field that is about 1% as strong as Earth's. This unexpected discovery, made by NASA's MESSENGER mission, surprised scientists because they didn't expect a planet as small and slowly rotating as Mercury to maintain a magnetic dynamo. Further intrigue was added by Dr. Katherine Johnson, a planetary scientist from the University of British Columbia. Her team discovered that Mercury's magnetic field is offset from the planet's center by roughly 20% of its radius. This offset could result from variations in the thickness of Mercury's crust, which influences how heat is distributed from the planet's interior. The surprises don't end there. In 2020, scientists announced the detection of volatile elements on Mercury's surface, including sulfur, potassium, and sodium. These elements typically evaporate quickly at high temperatures, so their presence on a planet so close to the Sun was unexpected. Dr. Patrick Poplawski from Johns Hopkins Applied Physics Laboratory proposed that comets or asteroids could have delivered these volatile elements to Mercury after it formed. One of the most remarkable recent discoveries on Mercury is the presence of water ice in permanently shadowed craters near its poles. Dr. Nancy Chabot, who was also involved in this research, found that despite Mercury's proximity to the Sun, these craters remain cold enough to preserve ice due to their lack of direct sunlight. Adding to the excitement, scientists have found evidence of organic compounds in the same craters where water ice was discovered. These dark deposits could be complex carbon-based molecules, possibly similar to the ones that may have contributed to the origin of life on Earth. Despite the harsh environment, could Mercury hold clues to the beginnings of life in our solar system? Another significant revelation about Mercury is its unexpected geological activity. For a long time, Mercury was thought to be a geologically dead world, but MESSENGER data indicated recent volcanic activity. Dr. David Rothery from the Open University in the UK found bright spots on Mercury's surface that are believed to be volcanic vents. These features, called hollows, suggest that Mercury could still be geologically active today. One of the most perplexing characteristics of Mercury is its chaotic terrain, an area of disrupted hills and valleys near the South Pole. First observed by the Mariner 10 mission in the 1970s, this region spans an area roughly the size of Texas. Dr. Thomas Waters from the Smithsonian Institution proposed that this terrain might have been shaped by massive earthquakes triggered by the Sun's tidal forces as Mercury's orbit shifted. Additionally, recent investigations have uncovered intriguing information about Mercury's structure. Dr. Amir Khan from the University of Zurich utilized data from the MESSENGER mission to study Mercury's interior. His team discovered that Mercury's core is composed of a liquid outer layer and a solid inner core, similar to Earth's. However, Mercury's inner core is proportionally much larger than Earth's, which could provide insights into some of Mercury's unusual magnetic properties. The fascinating discoveries on Mercury continue to challenge our understanding of how planets form and evolve. Even within our own solar system, there are many unexplained mysteries. Hold on, because Mercury's surface may have shocked you, but what's hidden below will leave you questioning everything. Mercury's hidden depths. Recent investigations and ongoing missions are revealing that Mercury's underground regions hold secrets that are just as fascinating as its surface features. One of the most intriguing aspects of Mercury's subsurface is its core structure. Unlike Earth, which has a solid inner core encased in a liquid outer core, Mercury's core is primarily liquid with a solid inner portion. This unique composition was confirmed by NASA's MESSENGER mission, which utilized slight variations in Mercury's gravitational field to map its internal structure. The solid inner core of Mercury is estimated to be approximately 1,260 miles or 2,000 kilometers across, accounting for nearly half of the planet's core. In comparison, Earth's inner core only makes up around 20% of its core volume. This difference in proportion plays a critical role in the generation of Mercury's magnetic field, which, although much weaker than Earth's, is surprisingly strong given Mercury's small size. Beneath the crust of Mercury lies a mantle that is thinner than previously thought. Studies now suggest that this mantle might be just 260 miles or 420 kilometers thick, while Earth's mantle measures about 1,800 miles or 2,900 kilometers. This relatively thin mantle has significant implications for Mercury's geological activity and the way heat is distributed through the planet. One of the most thrilling discoveries about Mercury's subsurface was made in 2012, when MESSENGER detected evidence of ancient volcanic activity. The spacecraft identified shallow depressions, known as hollows, that appeared to form when volatile elements sublimated from the planet's surface. These hollows indicate that Mercury's interior once contained more volatile elements than scientists had previously assumed. In 2020, researchers using MESSENGER data made another groundbreaking discovery beneath Mercury's surface. They uncovered evidence of a large underground reservoir of magma from Mercury's distant past. This ancient magma ocean likely played an essential role in shaping both the surface and the internal structure of the planet. This ancient magma ocean may explain some of Mercury's unusual surface features, such as the vast, smooth plains covering much of its northern hemisphere. These plains, referred to as the northern volcanic plains, are thought to have resulted from massive lava flows early in Mercury's history. However, the most shocking discovery about Mercury's subsurface came in 2022. Researchers analyzing MESSENGER data found traces of nitrogen trapped below Mercury's surface. This nitrogen may be a remnant of an ancient atmosphere that was driven underground by the intense heat and solar radiation that bombard the planet. The presence of nitrogen in Mercury's subsurface raises intriguing questions about its past. Could the planet once have had a more substantial atmosphere? If so, what might this tell us about its early climate and even the possibility of habitability? Another interesting feature of Mercury's hidden depths is the presence of water ice in craters near its poles, which remain in permanent shadow. Although this ice is technically on the surface, it is hidden from direct view, protected by the extremely cold conditions within these shadowed craters. Some studies suggest that this ice might be relatively fresh, possibly deposited by comets or asteroids within the last tens of millions of years. In addition to water ice, these polar craters are also home to dark deposits that scientists believe might be organic compounds. These compounds, more volatile than water ice, could be remnants of comets or asteroids that impacted Mercury. The preservation of these organic materials within Mercury's subsurface offers a unique opportunity to explore the distribution of organic compounds within the inner solar system. Mercury's subsurface also offers insights into its tectonic history. While Earth has plate tectonics, Mercury does not, but there is evidence of significant contraction as the planet cooled over time. This contraction led to numerous thrust faults, where one section of crust is pushed up over another. These faults, which can be several kilometers high, give us a window into Mercury's subsurface composition and geological past. Recent studies of these thrust faults have revealed something unexpected. Mercury might still be tectonically active, In 2019, researchers found small landforms known as grabens in association with some of Mercury's larger faults. These grabens, which are small valleys formed as the crust stretches, appear geologically young, suggesting that the planet's crust is still moving and shifting. Mercury's magnetic field is another mysterious aspect of its subsurface. While Earth's magnetic field is generated by the movement of molten iron in its outer core, Mercury's magnetic field may be produced by a different process. Some scientists propose that it is generated by a dynamo effect within a thin layer of liquid metal encircling a solid inner core. Another intriguing element of Mercury's hidden depths is the possibility of subsurface faults and fractures that might create pathways for heat and potentially even fluids to move through the planet's crust. Even though Mercury's surface is dry today, some researchers speculate that there could be pockets of liquid water deep beneath the surface, kept liquid by residual heat from the planet's core. The idea of subsurface water on Mercury might sound improbable, but similar phenomena have been observed on other seemingly inhospitable worlds within our solar system. For example, Jupiter's moon Europa and Saturn's moon Enceladus both have subsurface oceans beneath their icy surfaces. Although Mercury's environment is quite different, the potential for subsurface water cannot be completely dismissed. As we continue to investigate Mercury's hidden depths, new questions emerge. How has the planet's internal structure evolved over time? Could there be other volatile elements or compounds lurking beneath the surface? And perhaps most fascinating, what might Mercury's subsurface reveal about the early history of our solar system and the processes that shape the inner planets? These questions underscore the importance of ongoing exploration of Mercury. Each new discovery about its hidden depths not only expands our understanding of this extraordinary planet, but also provides vital clues about planetary formation and evolution throughout the solar system. Looking ahead to future missions and discoveries, one thing remains clear. Despite its small size and proximity to the Sun, Mercury still has many mysteries to uncover. Its hidden depths contain valuable insights into its history and possibly the history of the entire solar system. What a fascinating journey, right? Share your thoughts about what other surprises might be lying in wait on Mercury. Could we find rare minerals or even clues to extraterrestrial life? If you enjoyed this video, don't forget to hit that like button and subscribe to the channel for more updates. Thanks for watching and see you in the next one.